We are here. Welcome everybody to Modern Day Debate. Tonight we're going to be debating, is gravity a hoax? And we have Ross here, Iron Horse, to get us started. So you have up to 10 minutes on the floor. Thank you so much for being here, Ross, and it's all yours.
Yeah, thank you, Ryan, and thank you, Grayson. This was a rather impromptu debate. It only came up at the last minute in the last day or so. So I've written a quick introduction this morning. I'll start right away. A big thank you to Modern Day Debate for hosting this rather impromptu debate. My opponent, Grayson, for being so brave, speaking on a topic that history is no doubt going to thoroughly laugh at, that intelligent human beings once cling to as modern science. The cogs of dissonance grind slowly, and I'm here to douse them with good oil in the hopes that mankind can finally return back to sanity. A 14th century English philosopher is recollected in every thinker's mind when deciding which explanation is usually the best one, the simplest. While he himself cannot be attributed as the direct author of these words, enti non sunt multiplicanda praeta necessitate, the spirit of his law and parsimony translates as, entities must not be multiplied beyond necessity. This is the spirit of Occam's razor. Famous inventor Nikola Tesla is renowned for multiple game-changing inventions and is often quoted, sometimes falsely, sometimes out of context, but it cannot be doubted what he meant when speaking about modern scientists of his era. When speaking about Einstein's relativity theory, quoted in the 1935 New York Times, Einstein's relativity work is a magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. Another lesser-known quote by Tesla goes, "We are all one. People are interconnected by invisible forces. Although we have freedom to think and act, we stick together like stars on the heavenly arc with unbreakable connections. These connections cannot be seen, but we can feel them." Before I move on, I find these words of wisdom most timely as well. Of all the forces of friction, the one which mostly slows down human progress is ignorance, the thing called by Buddha the greatest evil in the world. So, is gravity a hoax? For that, we must ponder several possibilities. A, it's a deliberate, deceitful hoax created by evil people to fool all mankind. B, it's an accidental hoax created in good faith by men trying to make sense of a world based on accidental or deliberate false premises. And C, it really isn't a hoax at all. It's truly a force unto itself, even if still not completely understood, and maybe someday we'll grasp a better understanding of it. Let's address point C first, as that's really all my opponent can claim and support anyway. The inverse square law of gravity, first proposed by Newton, says that the gravitational attraction between two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. In other words, the force of gravity is inversely related to the distance between objects. This presents as a huge problem for the spinning spaceball proponents because, yes, indeed, this is absolutely a flat Earth versus globe Earth debate, and gravity is one of the key necessities of the globe's existence, and obviously its greatest weakness. People like to say that vacuums don't suck, and while you can argue that one way, it's a bit like the push me, pull you. It's a two-way equation where neither explanation is right or wrong, yet both are simultaneously correct. The atmospheric pressure seeking equilibrium is the reason why, when a valve is released to let air back into a vacuum chamber, forces itself back in with great veracity. But it's equally true to say that the void within is sucking the air in. This can be demonstrated with a multi-tier vacuum chamber here on Earth, where, due to distance, gravity must necessarily be strongest. I'll use a three-tier chamber for simplicity, but the same principle applies no matter how many stories are added above. All three tiers can be operated remotely and sealed off from one another or opened up. At first, the entire chamber is evacuated of all air. We'll call the ground floor chamber section 1, then upwards to 2 and 3. They are sealed off altogether, then some amount of pressure is allowed into chamber 1 and sealed off again. Let's say we permit 10 psi of pressure into it, which means against every wall, floor and ceiling of the chamber, the gas is exerting an even pressure in every direction, equivalent to 10 pounds for every square inch of surface. Normal atmospheric pressure being a little over 14, so it's almost 2/3 of normal air pressure we don't even feel outside. If we now release a valve into chamber 2, gravity is absolutely powerless to prevent the pressure from going upwards and equalising with the void. In the principle known as Boyle's law, gases in a container exert equal pressure in all directions. And now, throughout this entire space, we have a pressure gradient of just 5 psi in all directions. Gravity did nothing to maintain a higher pressure at the base, as it's said to do all throughout the entire surface of the spinning space ball. When we open the third chamber, the same occurs again. Gravity is useless in holding individual gas molecules downwards. Their very nature is to be free to roam and, in accordance with Boyle's law, fill every available space evenly, now creating a psi of roughly 3 1/3 throughout the entire enclosed space. If this is how gravity behaves when it is at its strongest, it becomes impossible to describe how the planet maintains a pressure gradient all the way to the void of space, not just because gravity itself must get weaker and weaker, but also because to necessitate the reality of the fantasy ball going around the sun, it's not just the daily rotation of 25,000 miles on its axis we must concern ourselves with, but the very necessary and impossible orbital speed around the sun. While actual rotation is merely 1 1/3 the speed of sound, anyone who's ever watched footage of a railgun projectile understands the mind-boggling speed of a projectile moving some 8 times the speed of sound, where it effortlessly pierces layers of reinforced concrete and steel-plated barriers like a hot knife through soft butter. And it is often able to reach targets over 100 miles away, something impossible on a 25,000-mile circumference globe where there would be well over 1 mile of curvature drop hiding any possible target. Even the world's tallest building stands at just half a mile tall, the sort of curvature drop that should and must occur at just 60 miles of distance from any and every point on Earth's surface. However, the heliuists, dressing up their beliefs in mathematical garb, claim that their obloit spheroid maintains a constant speed some 10 times faster than this projectile in order to go around the sun for every 364.2 rotations of the globe on its axis, which segues neatly into our next point, where all dropping objects said to be free falling in air at 9.8 meters per second squared must necessarily fall in very specific sideways direction, different for every time of the day and different for every latitude, in order to keep up the illusion of dropping straight down and always maintaining that constant rate of acceleration. Here's my crude diagram here. Hopefully can be seen. We can see that objects on one side of the globe must necessarily be racing upwards faster than Mach 88 minus 9.8 meters per second squared, which would be on this side, in order to create the illusion of falling down. The objects at the rear are going the opposite, Mach 88 plus 9.8 meters per second squared. The objects moving forward on the sides must intrinsically know which sideways direction to fall at least 30 times faster than 9.8 meters per second squared, just to create the illusion of falling straight down. Meanwhile, on the other side of the planet, they're doing the precise opposite. People talk about raising the dead, walking on water, or turning water into wine as some sort of great miracle. But really, the everyday event of inert, dumb objects knowing intuitively exactly which direction to fall in order to create the illusion of only ever dropping straight down would have to be the greatest miracle of all time, yet we simply take it for granted. It's not that we don't believe in some sort of force to cause the universal up and down directions we observe here on the stationary planar Earth. However, while the true reason is still often debated, I personally find no greater explanation is required apart from relative density. The Earth appears flat and stationary because it is flat and stationary, and objects appear to drop straight down, give or take wind assistance, because they do simply drop straight down. An object in motion stays in motion unless another force acts upon it. Therefore, an object in free fall motion in a vacuum will drop forever unless some sort of force prevents it. This prevention force can be called resistance, and resistance comes from substance, from something tangible that we call mass. Even air itself has a resistance force, the reason why any accelerating object in free fall will eventually reach a terminal velocity and eventually come to rest, hopefully gently with the aid of a parachute in the case of a skydiver, when reaching solid ground, the place of greatest resistance. Resistance is a force due to density. Density can be described as the molecular makeup of the various elements from hydrogen as the least dense, increasing by increments all the way through to osmium, the densest naturally occurring element. We generally think of lead, gold, or mercury as the most dense among metals, while metals like aluminium are least dense, therefore lighter per volume. Therefore, in simple terms, we can describe weight, the defining word behind the Latin gravitas, from which we derive the term gravity, is simply weight of the mass is determined by the density of the mass times the amount or volume of the mass. Relative density of one object to its environment determines if it floats, rises, or sinks. It's really as simple as that. I've only got probably a couple of minutes left to go, so
You've only got
I'll leave it there.
yeah, I was just say you've only got 10 seconds, so that's probably a good place to wrap it there. So thank you so much for your introductory statement there, Ross. We appreciate you coming back to Modern Day Debate. And I want to remind everybody that Modern Day Debate is a neutral debate space hosting debates on science, politics, religion. We do hope that you feel welcome here, and hopefully you guys are being lively in the live chat there. And also, we do super chats at the end. So if you have a question for either of our speakers and you get it in now, it'll be asked with priority and early. So with that, over to you, Grayson. You have 10 minutes on the floor. Oh, your audio is not on. There you go.
Okay, sorry about that. Hi, I'm Grayson. My YouTube channel is Based Theory, where I do debates against all kinds of pseudoscience, religion, and I also am stepping into politics a little bit for 2024, so look out for that. Anyways, today is sort of a last-minute debate on gravity, so I sort of, in the last hour or two, I kind of put together a little presentation, so let me just share that. So you all can see my screen and everything?
Yep, we're good to go.
Okay, perfect. So yeah,
now.
just wanted to start out talking about like what is gravity, because I see a lot of people confused about what this is. So there's two answers. In Newtonian mechanics, gravity is an attractive force between masses. This can be measured. You can measure this gravitational force in newtons, which is the unit of force. You can do this in a number of different experiments, but most famously, a type of experiment called the Cavendish experiment. Now, I know that even just saying the Cavendish experiment is triggering to a lot of flat earthers in the audience, and they're all, spurging out right now in the live chat saying, "Oh, actually, the Cavendish experiment, don't you know? I'll go toe-to-toe with anybody on the Cavendish experiment." That might get brought up since it is just a direct measurement of gravity in newtons as a pseudo force. We now understand gravity to be a pseudo force, but that doesn't mean that you cannot measure it in newtons as a force. Pseudo forces like centripetal and centrifugal forces can still be measured in newtons as forces. So that's one way to measure gravity. That's the end of the debate, right? I just measured gravity. You can isolate this. You can do a Cavendish experiment that is isolated from electromagnetic forces. I'd be happy to go over one such example of that, but you can do it in a Faraday shield. You can ground it. You can discharge the surface. You can essentially eliminate electromagnetic interference in this experiment, and you can just measure gravity directly. That's the end of the debate. You've measured gravity. But let's move on to our actual current understanding of gravity in general relativity. So this is not like the end all be all. Maybe one day we will have an understanding of gravity on a quantum level, but right now general relativity is the current consensus theory for how we understand gravity. Now, this is not to say that Newtonian mechanics was wrong. It still gives us the correct answers. It's just that it's incomplete in what its understanding of gravity is. In general relativity, we understand that gravity is the curvature of space-time. So that's kind of what that picture here is illustrating in 3 dimensions as space-time is curved. But, what does that actually mean? How do we know that space-time is curved and that is what gravity is? Well, we make testable predictions. General relativity makes predictions. We test them and we see, hey, if gravity really is from the curvature of space-time, like general relativity is saying, its predictions should be accurate. And that is indeed the case. So I'm just going to go over 2 quick examples. The first one is called, it's called gravitational redshift. It's essentially time dilation with height in a gravitational field. So this is the paper that showed this on a really, really small scale, like just within a millimeter difference of height. So you can see here in the picture, there's that little capsule. And there's different tiers in this capsule, like the rungs on a ladder that you can see. And there's atoms at these different rungs, and they tick at a set frequency. And if the capsule is just on its side and they're all at the same height, all of the atoms tick at the exact same frequency. But as soon as you move that capsule to be vertical and the different atoms are at different heights, all of a sudden the ticking is not in sync. The ticking is going to be a little bit different for the ones that are higher up than the ones that are a little bit below. And that's because the strength of gravity is different for the ones up here versus the ones down here. And that is measurable and that is predictable. And you can use general relativity to predict exactly by how different those two ticks of those frequencies of that ticking of those atomic clocks could be. And the prediction is precisely matching with reality. General relativity tells us exactly how these two things should be different. This is literally a time dilation effect, a change in the passage of time. And it's exactly predictable using general relativity. If gravity really is the curvature of space-time, it tells us exactly what this should be, and we measure it and find that that is the case. The second example, so here's how we really know that it's spatial curvature, right? You could say maybe that's just a lucky guess, right? But how do we really know? Let's look at another much more impressive prediction here. So we're going to be looking at LIGO. So general relativity predicts that when two massive objects like black holes or neutron stars, when they collide, a wave of space-time curvature should be emitted and travel to us at the speed of light. But here's the thing, is that astrophysics actually predicts that the gravitational wave should hit us first before the actual burst of light from that event. And this is just because of the dynamics of emission and absorption and everything. The gravitational wave should hit first. That is a testable prediction. First, we have to build a gravitational wave detector, though, and that took a long time. So this is what we built. It's called LIGO. It won the Nobel Prize in like 2017 or so. Basically, there's two massive arms of this experiment, and you shoot a laser, and they're at 90 degrees to each other. And you shoot, and if there's even a little bit of difference in the space-time, like the actual length of these two arms, they're 4 kilometers each. If there's even just a little bit of difference, you measure that. And so you can tell, if a wave of space-time comes and basically things are getting a little bit longer and shorter and waving in space-time, you can detect that with this equipment. Here's an actual picture of it from a helicopter. This is the one in Washington. You can see that's 2 4-kilometer arms. That's 2.5 miles. And then I actually visited LIGO in Louisiana. That's me there on the right. You can see I'm at LIGO at one of the detector arms. And on the left, that's inside the control room while it is operational. So you can see that everything is lined up. The lasers are in a straight line. This also, just coincidentally, this LIGO also debunks flat Earth because the construction is basically impossible to do on a flat Earth. So we can talk about that some other time. I know that Ross said that this is a flat Earth debate. It's not actually a flat Earth debate. It's a gravity debate. We'll see if we get in that territory, though. So here's the kicker. They used that LIGO observation to actually detect a merger of 2 neutron stars. They detected that gravitational wave in both Washington and Louisiana. So they knew that that was just not just noise. They were actually detecting something real, and the signal looked the same in both. And then, just like they predicted, 1.7 seconds later, a completely different detector on the other side of the world saw the light that was emitted from the exact same spot in the sky. They said, look, gravitational wave, we detected it from right here in the sky. So we predict that there should have been a gamma ray burst from the same position. And what do you know? 1.7 seconds later, there was. That is the gold standard of scientific confirmation. A testable, falsifiable prediction was made and confirmed precisely. So yes, in conclusion, gravity is real. And we know this because of the numerous tested, confirmed predictions of general relativity, of which I only just highlighted a small subset. There's gravitational waves, gravitational redshift, like we talked about, but there's also gravitational lensing, the precession of the perihelion of Mercury, which was predicted back in the early 20th century. There's cosmological time dilation, where literally the farther things are away in the sky, the more slow motion they are moving. Explain that one with relative density, I dare you. There's Einstein crosses, like are in the picture here, where you literally see the same star multiple times in the sky because the light has been lensed by gravity in a way that is impossible for traditional optics to lens that light. This cannot be explained with relative density. So yeah, usually we get a different explanation from the flat earthers, like relative density or blah, blah, blah. But there's issues with all this, namely that they assume a direction. They assume gravity is down. They assume it's a 9.8. They can't explain where that number comes from. And yeah, they just they beg the question from the start by assuming the direction for this. So we're going to have to get down into that fact, explain why gravity absolutely cannot be relative density and why it cannot be electromagnetism, like some other flurfers claim, and why it has to be the curvature of space-time because of the wealth of testable, verified predictions that have been made using general relativity. So let's get into this. Thanks.
All right. Well, thank you so much, Grayson, and also to Iron Horse for your introductory statements. We are going to move into an open dialogue. So if you haven't already hit the like button, definitely give it a good smack. And also, once again, we are going to be doing our Q&A. Last little bit of housekeeping I always like to throw in there too is all the debates are uploaded to podcast form within 24 hours. Both of our speakers are linked in those descriptions. If you like what you're hearing from either of them, definitely check them out in their space. But most importantly, make sure you're subscribed to the Modern Day Debate YouTube channel so you don't miss out on these live events. Let's hand it over to you there, Iron Horse, to respond to some of what you just heard.
Okay, well, I did hear a bunch of gobbledygook. Starting with Cavendish, he says it's an experiment, whereas technically really all it is an observation. When we've got something such as a torsion bar with two weights suspended, one on either end, it can be said to never be perfectly at rest in the first place, and so it's just inevitable that it's eventually going to come to rest. You actually said that it measured something, that it measured it in newtons. Can you please describe to me how it measured this, and don't just tell me that it was. Tell me how it was measured and what was measured.
Okay, so it is an experiment, the Cavendish experiment. There's an independent and a dependent variable, okay? So the independent variable that you are altering that makes it an experiment is the distance between two masses, okay? You have two little sample test masses and you vary the distance between them. That's the independent variable. And then the dependent variable is where you measure the force that is between them as it changes with that changing distance. So there's the independent and dependent variable of your experiment, and that force is measured by the torsion balance bar, which can actually measure in newtons whenever you apply a torsional force to the bar.
That described nothing, because
I just answered your question fully.
The whole idea of it is that those things are attracted to larger masses nearby, not towards one another.
No, that's actually incorrect. They are attracted to each other. That's the experiment.
No, it's not.
It is.
I'll
share my screen. I would like to show you an example of the setup for this experiment here.
I know the experiment quite well.
Based on what you just said, it's clear that you don't. So let me share my screen.
It would be the equivalent of saying if you had two large cranes next to one another suspending big steel balls, that as they got reasonably close to one another, both the balls would be attracted to one another. That is not the Cavendish experiment.
Here's the experiment. Here is the experiment. This is the Cavendish experiment. This is the smallest version of the Cavendish experiment ever done. These are masses on the size of milligrams, and they are measuring the force of attraction between these two tiny little milligram masses. These two masses, these gold balls. You can see them here. This is an actual picture of this setup. So you have
it's actually not the two balls on the torsion bar being attracted towards one another, as I just told you.
Look, this ball, okay, is not being attracted to this ball. It's this ball right here. You can see my mouse, right? This ball is being attracted to this ball. These two are the balls that we are measuring the force between. The one
so one of those balls is stationary.
Hold on. Let me just get this out. One of the balls.
Well, you just said that the ones on the torsion bar were attracted to one another. So you completely.
Okay. If that was what you understood of what I was saying, I apologize for miscommunicating. That is not what I was saying. Let me explain what I was saying.
Apology accepted.
I'm trying to explain it, Iron Horse here. This ball right here, we are measuring the attractive force between this one, MT, and MS for this ball over here. Are we on the same page now?
Well, that's what I said from the start. That's what I'm asking you about. What force are you measuring and how are you measuring it?
That's what I've just been answering. So we're measuring the attractive force between these two masses here, and we are measuring it based on right here. You see that there's a little center of this bar right here. You're measuring the amount of torsional force detected right here. That is what a dependent variable.
What instrument measures that force? That's what I'm asking. That was my question.
The torsion balance. This little string right here is a measure of torsion that you can measure the torsional force. Or you can also, right here, what
That's
they've
just
done
like
is
a
to set
plumb
up a
bob
photo.
directly up and down.
They measured it in two ways. Okay, let me explain. They used a photodiode right here that bounces off a little mirror, and you can measure the amount of deflection, which then you can calculate what is the amount of force that is being felt by this torsional bar. There's two different ways to determine it.
How does that measure a force?
It's literally the instrument, and you get a number back that gives you a force recorded in newtons. This is a fact. Look, here's their data right here. Like, they're measuring the displacement of the bar right here, the displacement as measured by this photodiode, versus the frequency of moving. They're moving this back and forth, this first mass back and forth. That's the independent variable. And they're measuring the amount of force right here. You can see the force is right here marked on their actual graph here, their data. They're getting a force in newtons as the as the dependent variable. This is the experiment.
Okay, so I understand how a scale works. It's sort of like a resistance measurement force. So, when it's got no weight on it, it measures at zero, so it's grounded. So you put a weight on it. We can physically measure a weight. What instrument are they using to physically measure this force?
Again, they're measuring the calculation with the photodiode and then using physics to calculate what force is being felt by that torsion bar.
Using physics, but what is the instrument, please? One more time. What is the
A
instrument they're using to measure?
photodiode is one instrument, and the second
That's a light
instrument is the
detector.
torsion wire. Have you ever experimented? Have you ever used a torsion wire, Iron Horse?
A torsion wire sounds to me just like a plumb bob. It just measures
No,
a universal
it's
up and down perpendicular force to the surface of the ground.
You can use a torsion wire to measure the amount of torsion in newtons as a force. Like, I'm sorry that you don't have experience with torsion wires and photodiodes, but it's not my responsibility.
The whole point of the Cavendish experiment, the whole point of the Cavendish experiment is that it's perfectly balanced. Hence, it's a torsion bar with a weight on either end. What exactly are you measuring? And how are you doing it?
Explained it. Oh, okay, literally,
you're not explaining anything. You said a photodiode. That's like a camera uses. You're measuring light.
You start in a balanced state, right, where the forces are balanced, and then you introduce another mass, which then has an attractive force with one of the ends of that bar, and you are measuring the amount of torsion that is introduced to that bar. That is what you are measuring, the torsional force. Can you get that through your head?
You're not explaining how it is being measured.
I've gone over it multiple times now. What do you want from me? I've explained to you.
You're obfuscating it. You're just saying, well, physics does it and light does it. You've mentioned nothing.
Like, do you want to read through this paper? I can send you the link where they go through their entire methodology, and you can go to your heart's content, and you can get all the answers, all the questions answered that you want.
Well, you're the ones explaining it. I just want a simple layman's terms. What device are you using to measure this force? And you can't give me one.
Torsional wire and a photodiode laser. Am I speaking English?
Diode laser. Okay. All right. Well, obviously you don't know that.
Are you not picking up? Like, do you doubt this experiment? Are you saying that this experiment is a hoax or it's not real or what?
Well, absolutely, I am actually, because if the Earth's mass is so incredibly strong, then such a tiny ball would be insignificant compared to the Earth's downward force. That you'd need something, 10 times size of an elephant to create the slightest little effect against Earth.
Do you understand how you add up force vectors? Like, this is high school physics.
Add up force vectors.
Yes.
Something so tiny compared to something so massive creates a greater force.
No, and it's measurable. Yes, there's nothing against this other than your own personal incredulity. There's no physics against this. You are literally, if you did a force, like a free body diagram of this situation, and you drew each force that was affecting this mass, you would account for the Earth's gravitational attraction to it on both of them, with a direction going down. And then you have a tiny little arrow going sideways, and that's what you're measuring with the torsion. You know why? Because the force of gravity is perpendicular to the direction of torsion, so it's not affected.
Okay, and it's also well known that the Cavendish experiment doesn't always work. We also know that you have to invent something like 95% dark matter to explain why the universe doesn't provide.
Changing the subject. Come on.
Into a singularity.
All right, let's finish his thought. Let's let him finish his thought, and you can address after there. Just let's give him some space. Go ahead, Ross.
Yeah, it's also well known that you have to introduce 95% dark matter to prevent the entire universe colliding into a singularity. You have to have dark energy to stop it from spreading apart. You've got everything except visible proof of gravity. You've nothing but theoretical garb in order to make your theory of attraction even possible. As Tesla even said there is this invisible force which everything in the universe operates by, which we can also see in things like pendulums, which change via latitude. We can see it in the star rotation themselves as the stars get further from clouds, they move in larger and larger circles. So there is this invisible energetic force constantly surrounding us that everything responds to. And it's just as likely that the Cavendish experiment is reacting to something like that as well, like just some sort of invisible force, which is not gravity. It's not a attraction of mass.
Okay, so you're done there. You brought up a whole lot. I don't know even why you brought up dark matter because your ultimate point didn't even have anything to do with it, but okay. I don't see how dark matter is relevant, and you got dark energy and dark matter confused in their roles in cosmology anyway, but that's fine. You just got them flipped. But yeah, the evidence supporting the existence of dark matter is like coming from multiple independent sources that all corroborate and give the same exact value. At least 6 or 7 different independent sources of methodologies to support dark matter. You have a couple for dark energy as well. Like this is not just one observation that's telling us that these things actually do exist, despite us not knowing like exactly what they are. We know that they exist from their actual evidence, from gravitational lensing, galaxies rotating, like bullet cluster. I just feel like this is just so off topic to even bring up.
Well, that's absolutely the topic, because if you didn't make up gravity in the first place, you wouldn't need to make up invisible dark forces that you can't even see or detect, but you know must be there. So obviously gravity is wrong to begin with, and we can scrap the whole idea and start with something which actually works.
So let me clarify, because that is incorrect. Even if we scrapped gravity, if we completely got rid of the entire idea of gravity, we would still have dark matter. Like we wouldn't just get rid of dark matter by doing that. We would still not have an explanation that needs dark matter to solve based on our observation.
Please explain why. You assume everything in the universe is actually physical matter or something equivalent to what the Earth is made from. Whereas, as far as I'm concerned, Earth is the only physical plane in all of existence, and all the lights in the sky are not terra firma whatsoever. So we don't need gravity to explain why and how they exist. They exist in a different form of medium altogether once we leave beyond the firmament, which is above us, and they are in a different sort of medium and obey completely different rules. What we see and experience here in the physical plane is what we see and experience. And so we don't have to try and explain the entire universe when all we're really trying to describe is what is here and now, what is beneath our feet, what is in front of our faces, how all the laws of physics behave according to observations, as opposed to hypothetical things about things that happen beyond the curve where we can't see them, out of sight, out of mind, beyond this curve, which we've never seen.
I was trying to let you finish, but you never seem to finish. But okay, it is actual observations that you need to explain. You can't just say, well, we don't need to explain actual observations of the universe because, like, we're only concerned with what's happening here. Again, like, you were the one that brought up dark matter. And now when I bring up observations that you need dark matter to explain, all of a sudden, oh, I don't care about those observations. We only want to talk about what's here on Earth. And now it's a flat Earth debate. Okay, I thought you wanted to talk about dark matter, so let's talk about one observation that you can't explain. The bullet cluster. Are you familiar with it?
I'm not familiar with the bullet cluster.
Okay, so it's one observation that cannot be explained by any theory of electromagnetism or any theory of modified gravity. You need dark matter to explain the behaviors of the bullet cluster. What happened is these two galaxies, like literally, were on a collision, and the actual movement that they had when they were colliding, okay, it cannot be explained with electromagnetism, with relative density, with some sort of ether. You can't explain the way that it's moved, except for if there's an invisible dark matter component, which you can actually literally see where its density distribution would have to be in order to get this sort of movement. Because what it looks like is happening is that these two galaxies are moving around nothing. It looks like there's some invisible thing that these galaxies are moving around and feeling a force from. But if you don't have dark matter, there's no explanation for it.
Okay, well, that's a cool story, bro, because I wasn't talking about other galaxies and so forth. I mean, even our nearest star, according to, heliocentrism, is, some multiple light years away. So obviously these galaxies, each of them would still have, spaces unfathomable between one another. So anyway, hopping off completely, as far as I'm
Okay,
concerned,
no,
off
don't
topic to start
accuse me
talking
of
about
doing that.
galaxies.
You were the one that brought up dark matter, and this is one
Yeah.
of the pillars of evidence supporting dark matter. You were the one that said, without gravity, we don't need dark matter. I am bringing this up as an example to clearly show that even without gravity, you cannot explain the behavior of the bullet cluster, which requires dark matter. This is a
No, but
direct refutation of your point. You brought this up, not me.
yeah, but you're making the assumption that these galaxies are physical matter in the first place, and that they
We can
behave
look
in
at
the
their
same sort of
spectrum.
laws as to which we observe here on Earth, where you assume that we have gravity, and then you have to assume dark matter to stop everything else behaving because you've already assumed that they're physical stuff in the first place. Where I say there's no such thing as anything physical outside of the realm upon which we live.
Okay,
and so once you remove that assumption, then all of your pseudoscience is no longer necessary or required.
It's not an assumption. This is just a fact based on observations from like spectroscopy, for example. We can look at what elemental composition these distant objects have by their spectroscopy.
No, that's not true whatsoever. We can say that the spectroscopy is entirely due to the atmospheric gases and the way these things stimulate it to create light visible to our eyes. So all of this could be only happening because of our observations from here on Earth, looking through our atmosphere. And once we're above the atmosphere, as we see in high altitude balloon footage, there are no stars visible whatsoever. All we see is the one giant big sun, and we see a tiny dot which represents the moon, and that is all that is visible from above a certain height. So we know the importance of our atmosphere is the real giver of light, and all of spectroscopy happens as we see through our atmosphere and the various gases that are stimulated by these objects.
You made the same point multiple times. Let me respond.
Well, that's right. It's important.
Are you familiar with the fact that we have observatories above the atmosphere, like the James Webb Space Telescope, that do spectroscopy without having any atmosphere intervening? Right? There's no atmosphere.
I believe they only use radio waves. They use radio waves only, and they don't use spectroscopy whatsoever.
They literally do spectroscopy, yes. Everyone can look that up and see that the James Webb Space Telescope does spectroscopy, yes.
Yes, and NASA hires really good artists to try and turn them into pretty pictures, which are all man.
It's all a conspiracy. It's all a hoax. But you know
what?
How's
that a conspiracy? It's proven. We've seen interviews of the artists themselves who admit that that's what they do. That's their job. That's not a conspiracy. This is an observable fact. Anybody can search.
Ross, I challenge you. I challenge you in front of everybody. Find me one example of an artist saying that they created a spectrograph.
A spectrograph?
Yes, the actual spectroscopic layout showing the elemental composition of a distant galaxy or star. I want you to find an artist admitting to making that up. Find it for me.
It's hardly the time and place in the middle of a debate for me to start researching stuff.
Okay, I got you. Because
this is something we've all seen before. Anybody who does their research has seen this before. There's plenty of interviews of NASA.
I challenge everybody in all the comments, everybody on YouTube listening to this, try to find an example of an artist admitting that they made up a spectrograph. You can't find it.
I didn't say they made up the spectrograph itself. I'm just saying that they make up all the pretty pictures that we've seen. Every single last one of them.
Picture. I'm talking about actual data, a spectrograph, which shows the elemental composition of distant stellar objects.
Look, the spectrograph can be absolutely perfectly correct. I'm not arguing that. I'm just saying that they're all pretty pictures made by artists.
No,
and maybe they're using the spectrograph as a guide.
Because you're saying that we don't know that these distant objects are material. But if you're saying that the spectrographs are accurate, then we know beyond a shadow of any doubt that they are in fact physical, because we can tell what atoms they're made up from the spectrograph.
No, you can't. You can just tell what colors they produce in our sky visible to us through our atmosphere.
We can literally see the emission spectrum corresponding to the exact elemental composition.
Okay, so obviously you're personally invested in this. We've seen that because you visited the place. You said, and you even said that this thing that's called phonetically called a go lie, even though we call it a lie go. You said that it's impossible to build on a flat Earth. How is it impossible to build something 2.5 miles long or 4 kilometers in a perfectly straight line on a flat Earth when that would be the most ideal location to do it on?
Because it's not level. It's actually curved. And if it was on a flat Earth, it would have to be perfectly level and flat. But in reality, they had to compensate for the curve of the Earth by actually raising up one end and having the whole thing slightly off level. In fact, if you take a level, I'll let you finish here. If you take a level and you were to put a level on top of that tube at LIGO, only one part around the midway would be flat. and like perfectly level. And then you go off to the side, it's no longer level. And then when you go off to the other side, it's no longer level, but it's perfectly straight. It is so straight that level would not suffice, and they could not make it level. They had to make it straight.
And you do have evidence of this, I presume?
Yes, absolutely. I can share my screen and I can show you the actual engineering documents that for the actual company that created the arms of LIGO, and they had to figure out how to make it straight. And they specifically say that level is not straight enough for their purposes.
Okay.
If you want to share it, you can go ahead. I have it ready.
Okay. Oh, wait. This is the wrong LIGO paper. Let me share. Sorry, it's kind of hard to find where I've got all these papers. Here we go. I think this should be it.
Science gets tricky, doesn't it?
All right.
So this is the precision alignment of LIGO 4-kilometer arms using dual frequency differential GPS. Here's like the engineers, the company, where they did it. They explain their entire like process here. You can read how they got this so straight that it couldn't be level. It's all documented here. Everybody can see the title, the authors. Go look it up yourself and read this document. And this single document makes flat Earth impossible.
Okay. And so have you ever heard of the thing called the Tamarack Mine Mysteries, where in actual fact these geodetic scientists back in around the 1900s went out in the field and tried to physically measure the circumference of the Earth, and they wanted a better example than the Eratosthenes experiment, where they just measured shadows of the sun. Whereas, because as we know, if you measure shadows of the sun with a nearby local sun, all that Eratosthenes really measured was actually the path of the sun, which just so happens to be the equator. So you get
Ross, hold on. Is this on topic for gravity, or are you talking about flat Earth stuff now?
This is on topic for gravity.
Are you sure this is about gravity? Because it sounds like flat Earth.
Just let me speak and you'll see where I'm going with this, okay?
Sounds like flat Earth.
Okay, good. Just button it. Thank you. So as I was saying, the best way to measure the circumference of the Earth would be to use gravity to suspend long plumb bobs down towards the center, because everything is attracted towards the center according to the laws of your gravity. And it's more practical than erecting mile-high poles, measuring the distance at the top and measuring the distance at the bottom. What they did is they suspended long plumb bobs down deep mine shafts in order to measure the distance at the top compared to the distance at the bottom, which should be less, and therefore they could use a formula to determine a more accurate circumference for the circumference of the Earth. But what they found in every example is that the plumb bobs actually got further apart towards the bottom. And in fact, when they finally selected two mine shafts a mile apart at the surface, at a mile depth, joined by a horizontal shaft at the bottom, they were 1 mile, 8 inches apart at the bottom, which is the exact opposite of expectations of globe Earth measurements. So you were saying that they are using gravity to measure the levelness of this GOLI system that you're talking about, and yet real science found that using gravity to measure level goes the opposite direction of expectations. How do you explain that?
Okay, so one, LIGO is real science. I mean, they're doing real science there. They are measuring gravitational waves. That is real science 100%. Two, could you repeat the name of this? Because I haven't heard of this mineshaft experiment with plumb bobs, and I would like to look more into it, but obviously without being familiar with the actual material, I won't be able to weigh in on it. So I'd like to look it up for a later point. So remind me the name of this so I can just jot it down.
Okay, you'll probably have to go to a library to find most of the information.
Just tell me what the name of it is called.
Because looking online will give you very little. It's called Tamarack, Tamarack, Mine Mysteries. That's the general thing. If you search that, you'll find a little bit of information about the guy who reported on it in one of the scientific journals. The Tamarack Mine Mysteries is quite well known. I first read about it in a book which is actually called Secret of the Ages, which is talking about a hollow Earth. And this guy was proposing that we live on the outside surface of a hollow Earth. But really, after you follow that experiment, you have to presume if we were living on the inside, as the concave Earthers like to say, that makes far more sense, where gravity could be explained by the rotation of it, which is what NASA often proposes for a spaceship designed to artificially simulate gravity in space, would be to have it spinning. So that if we're on the inside surface, rotating fast enough, that could actually explain how gravity even works. It's like a centripetal force. Water would still seek and find its level. The atmosphere would still move with us. Planes flying high would fly shorter distances. So if we lived on the inside of the Earth, it makes far more sense than living on the outside, hurtling through a vacuum of space, where gravity is a necessary requirement to make it possible that people could live on the outside surface, either on the sides, the bottom, the top. Everybody's on top in all
right.
directions.
We'll have to pass
Okay,
the ball here soon.
That is what
You've been
gravity
going
is
for a
required
while,
for in the
Ross.
first place.
Yeah,
Yes, but I'm just saying that is why you've invented
Well,
gravity.
I know you're just
to make your
saying.
ball
You've been
possible.
just saying for a while. Let me get in on this.
Yeah.
Okay, so like I will look into this tamarack mining mystery. To me, immediately off the bat, it's very suspicious that there's not much information about it online. I'm suspicious about where you learned it from, but immediately when I look it up, it looks like some kind of thing from the early 1900s that hasn't been reproduced since. So my question for you, because all kinds of things could cause these results from like literally just like air fluctuations in the tubes. So I want to know, right? Have we verified these results by repeating them in the preceding 100 years since? Have any flat earthers done an experiment of this and repeated the results of the initial tamarack measurements?
Okay, so we're talking about something, in an area where men were men. To go a mile depth down a mine shaft is no mean feat in the first place. This is some serious sort of science where men got their hands dirty. It's the sort of thing they did repeat many times. They sent their results off to the French and asked them to repeat it. And they eventually found that it was so conflicting with everything that they thought they believed that they basically swept it under the rug and promptly forgot all about it.
Conspiracy.
That's basically how science does it. When they get something wrong that goes against all beliefs, they just ignore it and say, well,
no,
yeah,
that's
let's
not
pretend
how
that never
works.
happened.
You want me to give you multiple examples just from within the last like 2 years that science has gotten surprised and something has gone against the scientific paradigm and we've had to change and not just cover it up and sweep it under the rug? Like that happens multiple times, all the time in science. It's very common and it's very exciting because it's how scientists make their careers. Like the scientists who discovered, like if this is what you're saying is accurate with these mine shafts, a scientist who discovered this and documented it and verified it would like be famous. They would make their entire career. They'd be incentivized to do this, but you're just saying, oh, they're covering it up. They could repeat it, but they don't want to. They want to hide the truth. Okay, it's just going to fall back into conspiracy. So let's just get back on track.
Look, that's how you dismiss everything. Just call it a conspiracy. It's so easy for you to just call it a conspiracy.
You're dismissing everything. You're saying that,
no,
okay, all the evidence I brought forward, it's a conspiracy. And the evidence that you brought forward, it's being hidden because it's another conspiracy. Everything is a conspiracy in a handwave for you.
No, I think you hit the nail on the head when you say these men make a career out of it. You have to make a career, you have to have somebody who is willing to pay you to do something. And if you don't give them the results they want, well, you're not going to get paid. You're going to get dumped and you're going to get thought of as a crackpot theorist. And that's why flat earthers do not have a career in science, because we question the science. We question all of the nonsense that you guys bring up, whereas you guys have to keep on whacking each other on the back and getting peer support from one another. You can't do anything new in science without being shunned. And if somebody did prove the Tamarack mine mysteries, they would get kicked out of science. They would be considered.
So here's the thing, though. Here's the thing: is that like you are getting paid to get like develop scientific progress, get attention and prestige for your institution. And what's a good way of doing that? Oh, making a scientific discovery that changes the paradigm and challenges the consensus and makes us change the consensus because you brought the evidence to back your claim and overturn the consensus. That's why flat earthers cannot get their scientific careers off the ground, because they cannot provide the evidence that demonstrates their claims. They can claim a lot of stuff, but then when it comes to actually providing evidence, that's why it's not science, because they can't. And we could talk about this with the relative density stuff, because Ross is making a claim about what gravity actually is. He says it's caused by relative density. So let's talk about that and why that is impossible.
All right.
Yeah, well, that's why flat earthers are not out to make a scientific career on it, because they know that nobody's going to be paying them to give them information that proves that they are wrong, that there's no force of attraction, that the only force is resistance, and resistance comes from density. Therefore, relative density is the true explanation for how things either float, sink, or rise. That's all that is required.
Let's pop that balloon. Let's explain why it cannot in any way, shape, or form be relative density, right? So you have a column, right? And the column has different levels with different like mediums that have different densities in them, right? Like oil or water or whatever. You have a column of
in the liquid form,
different layers, right? Okay. So then if you put an object to it, it'll go to, sort by its relative density, whatever. The thing is that Ross needs to explain why there's a directionality in this column to begin with. Why is it that the more dense stuff is on the bottom and the less dense stuff is on top? And why is it that you can actually go into like an airplane, right? You can have like those little free falling airplanes where you're in the airplane, all of a sudden you're experiencing basically zero gravity because you're in free fall, right? And you kind of simulate it like, oh, that's so interesting and cool. So if you took this column and took it to the zero gravity weight, right? And then you introduce an object in between that density there, what's going to happen? Is the object going to be sorted by the relative density? No, it's not.
Right.
And why? Because you're in gravity.
All right, let's hand the ball back over there.
There's definitely no such thing as zero gravity. Even the ISS is apparently 95% Earth's gravity, and they say it's 250 miles high. So that's clearly false. Basically, everything is resistance. And if you think of acoustics, for example, is a good way of thinking of it. Is sound, we say that the higher sound is always the lighter tone. The deeper sound is the more bass things. Everything in physics requires a base. The base is the form of resistance from everything starts. So the density tower itself has a base and then has solid walls. And everything finds its place when it's at rest. Once it's at rest, that's where we get the word resistance from. So everything that once it's at rest has resistance to one thing to another. When everything is in free fall, which is what you falsely call is zero G, it's actually everything is just in free fall in an enclosed capsule, creating the simulation of zero gravity because everything's falling at the same time at once. Well, everything is just free to drop at the same rate. It's the rate of drop is not determined by the density of the object. Otherwise, heavier objects would always fall faster than the others, but everything is falling at exactly the same time. Once it comes to rest, then the things will form themselves according to their relative density and give us the density tower that we see. You need resistance and at rest from the base of the tower.
I don't think that you've fully understood that you've just got here with this example. So really, I want you to like actually visualize what we're talking about right here. Like the column, it seems like you got the column, it's got the different levels of different density, and you've got a really heavy little lead ball, and you drop it just in a normal room, right? And that lead ball goes through all those different layers of density, right? And it goes all the way to the bottom. And then when you go up to an airplane, you don't like when I say zero G, I don't care. I'll just say free fall, right? Because you understand when you're in free fall, then you're all of a sudden you're not like everything around you is not falling like you're in the room anymore. If you were to introduce that lead ball in that airplane in free fall, it would not fall through those different layers of relative density, even though the same densities are still in the same layers as before. There's no change in any of the relative densities. All the same relative densities are in all the same order. They're in the same order in the column. You have not changed anything about the relative densities.
Let's let Ross jump.
The only thing that you've changed are in free fall. And when you drop the ball, it doesn't fall. Why not?
That is absolutely not a gotcha. That is completely false because I'd already described that, because everything is in free fall at the same time. And we know there's a universal rate of drop of the 9.8 meters per second squared. That is just the rate of drop as we observe it. And everything, in fact, inside the density tower will actually start to reverse given sufficient amount of time in dropping. The base will end up becoming the top, and the things will reverse form. And so the lead ball should stay at the top. Everything is falling at the same rate. It's only when it comes to rest and stops that the form of resistance comes from the base once again, and then they will reverse back into the normal structure. So you got no gotcha on me whatsoever.
Ross, you're not understanding. You're not understanding the gotcha here, right? Because you are saying that what is causing the motion, this downward acceleration that I'm calling gravity, you are saying that what is causing that is the differences in relative density of the medium to the object. But in free fall, in this density column, you have not changed anything about any of the relationships for any of the densities of any objects involved or the mediums. The density relationships are all the exact same. And that's what you're saying is causing this downward acceleration. But all of a sudden, we haven't changed anything about the densities. The downward acceleration is gone. So therefore, we know that downward acceleration cannot have been caused by the relative densities.
That's where you're wrong. I don't say that anything is causing a downward acceleration. I'm saying that the downward acceleration is allowed to permit because of the lack of resistance. And that's the lack of resistance from the density of air. That's why even a vacuum, it's the perfect lack of resistance and everything will drop at exactly the same rate. But when everything is in free fall motion inside the enclosed aeroplane, everything is in free fall There is no acceleration of one thing greater than another. Everything falls at exactly the same rate. So there's no reason for the lead ball to accelerate greater than the other things falling at the same speed as it.
Okay. So then the reason why, the cause for this downward acceleration, I'm glad you agree, is not relative density. So then relative density cannot explain gravity. So then what explains...
No, you're calling it attraction of biggity. Whereas
so
I'm saying it is relative density.
Ross, let me ask a question. What is it that causes this downward acceleration?
The density of air, the medium that it's in. Everything is in that medium of air, and everything being more dense than air drops at the same rate.
So, but as we already described, right, in the free fall experiment, you can change those densities as in an actual experiment. You change the independent variable of the density, and you're saying the density is what's causing the downward acceleration. So you change the independent variable, and you get no change on the dependent variable. You don't get any change in the downward acceleration, so they're not causative. So your hypothesis has been refuted.
That's rubbish. We're still in the medium of air, are we not?
It doesn't matter. You're in the medium of the density column, and you're introducing a heavy lead ball into the middle of this density column, and you're figuring out which way it goes. And
yeah, but the column is
when
dropping.
They're in free fall, when they're in free fall, all of those relative densities are in the exact same orientation as before. Nothing has changed about any of the relative densities. So therefore, nothing should be different about the downward acceleration if your hypothesis is true. But when you're in free fall, there is no downward acceleration. It's completely gone. So your hypothesis is false.
That's right. Everything is in the same accelerative field, the same
relative to each other, right? But that's the thing, is that you're saying that it's the relative density that's causing these downward accelerations. But we haven't changed anything about the downward acceleration. We haven't changed anything about the densities, and the acceleration is changing. Why?
Acceleration is not changing.
When you're in free fall, right? When you're in the airplane, I'm talking about the acceleration of the lead ball relative to the acceleration of the density column. That's what I'm talking about.
They're all dropping at the same rate.
So then so then their acceleration relative to each other is 0, Ross.
Correct.
Yes, that's right. What I'm saying. That's what I'm saying. So we are agreeing now that you have not changed anything about the densities, and yet you're
shooting yourself
relative to each other is 0.
You're shooting yourself in the foot, because I'm saying that relative density only happens when a thing is at rest. Once you bring the thing to rest, once it stops on the ground and you put your density tower on the ground, it is at rest, and then everything will sort itself in accordance to its own relative density.
That doesn't work, because if you throw a ball up in the air, right, it's not at rest, but gravity still works to bring it back down to the ground. So we know gravity doesn't work when you're at rest.
It's still more dense than the medium of air.
Come on, you're falling apart, man. Density can explain why it is downward acceleration.
Air does not give the ball buoyancy. That is why it falls through it. It does not resist it. The ground is more dense enough to resist it. Water is dense enough to resist it. That will give it buoyancy. Why would you expect air to give it buoyancy?
The ball's not at rest, and yet it's still being affected by gravity.
Yeah, but if thing stays at rest, will remain at rest unless another force acts upon it. So until you threw it in the air, it would stay at rest, and it would stay on the ground. But you're saying
that the other force is coming from differences in relative density, and that's creating a force that we call gravity. But I'm showing you that cannot be the case, because you can literally have two differences in relative density, introduce an object into them, and it doesn't move towards the least dense medium if you're in free fall. That refutes the idea that this could be caused by differences in relative density. It cannot.
Why would it? Why would it when it's in free fall? Everything is in free fall together.
I'm trying to make this very simple. We can move on, because I don't think that you're going to get this. I'm going to try one more time to explain this simply, okay? There's two examples, right? You have a lead ball being introduced into the middle of two different mediums. One's a less dense medium, one's a more dense medium, right? And you're saying that it should go towards its relative densities. It should fall down towards the least dense medium, right? Because the lead ball is more dense than the medium around it. And that's what's causing that downward acceleration. Is the differences in the differences in density between the lead ball and the medium around it, right? You're saying that's what's making that lead ball, because it's not being supported, so it's just going to go down, right? But when you're in free fall, when all of those density relationships are exactly the same, you haven't changed anything about the densities and how they are relative to each other. But now that lead ball just stays there. It doesn't move. It just stays there.
Actually, if anything, I would say it would rise to the top of the tower in appearance.
It doesn't, though.
That doesn't.
Because you know why? Because that movement, that pseudo force that's being applied to it, is not because of relative densities. That's the reason.
Is that relative density, as I keep explaining it to you, you seem a bit too thick to understand this, can only occur once the thing has come at rest. When a thing is in free fall, everything is in free fall at the exact same rate. And you've also removed the air resistance factor doing it inside an aeroplane because all the air is also dropping with everything else at the same time.
Look,
whereas if you did it in the open air, you would get more air resistance.
If you admit that, which you just admitted, then you are admitting that relative densities cannot be the explanatory factor, because you're saying that the differences in relative densities don't affect anything until the entire system, both the medium and the object, are at rest, right?
Correct.
But when both of them are in movement, you can still have gravitational forces acting, and you can still measure those gravitational forces. So this is how we know that density cannot be the explanation. It's literally ruled out, Ross.
No, you're just making stuff up now. You can't measure anything in free fall. A scale doesn't work in free fall. There's no gravity in free fall. Everything is just dropping at the same rate. A scale only works once it's at rest and sitting on the base of something that gives it resistance. If you try to put a scale in the bottom of a swimming pool, for example, then the density of the medium will prevent a person giving a true weight. But the mass of the person themselves hasn't changed whatsoever. It is the medium which is giving them buoyancy.
You can do the Cavendish experiment in free fall and still measure an attractive force.
I'm not talking about the Cavendish experiment.
No, but just I'm explaining to you that you can measure.
We're talking about relative density. Okay. And it's the density of the medium that determines. Like, I didn't quite get to finish my introduction. If I might be allowed a second just to describe one part.
It's the open discussion period. It's no longer a presentation.
Yeah, but it's relevant to this. I'm just going to talk about the basketball. A rubber bladder contained within an even harder outer surface that holds a more or less perfectly spherical shape. In the medium of air, an inflated basketball readily falls back to Earth no matter how high we throw it. The compressed air within it adds to its mass along with the outer shell, and this not only gives it great buoyancy, but also great bouncing effects upon the solid base beneath the feet of every one of us. If we throw it at the ground hard enough, it will bounce high into the air, yet it always returns as air is insufficiently dense enough to give it buoyancy. Throw it into a swimming pool, however, and it readily floats. It takes great perseverance and possibly even assistance to drag one to the bottom of a deep swimming pool, whereupon being released, it shoots with great vehemency towards the surface, shoots into the air before returning and finding a place of resistance on the surface, displacing its own weight in water according to the Archimedes principle. So the basketball, when we drag it to the bottom of a pool, will shoot up.
Yes,
anti-gravity.
Obviously. Why are you filibustering on stuff we agree about?
Because it's obviously not gravity. Gravity gets turned off at the bottom of a swimming pool where all that water on top of the ball should be holding it down even more so.
Do you know the formula to calculate density or buoyancy, Ross? Do you know the formula?
Well, as I said, the Archimedes principle, it's the displacement of its own weight determines whether it floats or not.
And you know that there is a G in the formula for gravity. A downward force, a downward acceleration is already accounted for in buoyancy.
That's not a downward force whatsoever. That's just
9.8 meters. Man, it's a downward vector with units of acceleration.
9.8 meters per second. It's 9.8 meters per second squared. And because the thing is floating, it is not accelerating whatsoever. So it becomes zero. And if you multiply anything by zero, you get zero.
You're accounting for G. You're not saying that this actually is moving at 9.8 meters per second. You just have to account for that acceleration in order to properly account for the actual value of its buoyant force. You have to account for that 9.8 downward acceleration.
But there is no acceleration. So therefore you make it zero.
That's the thing. I know you're saying that there is none, but it must be accounted for in order to get an actual accurate calculation of what the buoyancy is.
How is an object at rest accelerating downwards?
Because it's in gravitational field. That's how gravity works, Ross. This is the basics. This is the very basics of the basics.
How is something at rest accelerating?
Okay, it's literally everything in a gravitational field. This is the basics of how gravity works. Everything in that gravitational field is experiencing that downward acceleration vector all the time, no matter what its actual movement or not. You can have the forces that are balancing out so that overall the force is balanced and it's not moving.
Did you just say whether it's moving or not?
Yes. Because again, this is back to the basics
of a
free body diagram. I really don't know if you understand how to add up vectors when you're adding up like the forces that are acting on an object.
I'm talking about the basketball floating in water. Yeah, this is one body in a medium of water. And so when it's at rest, it's accelerating.
There are two forces
That
acting
is the
upon
most
it.
pseudoscientific thing
You
I've
gotta
ever
let
heard
me
in my
finish
life.
a sentence here, Ross. In order to figure out what forces are acting and what accelerations are acting on that basketball, which overall has a net acceleration of 0, you must
Ah,
add up all the different force vectors on it, including from gravity and the buoyant force that cancel each other out and yield overall 0. But that G, that downward acceleration, is still something that must be put into your formulas to calculate an accurate value for its buoyancy. You have to account for it. You can't just ignore it and say it's not happening. It doesn't exist. You have to account for it to get the right answer.
okay. So why is the basketball more buoyant in salt water than it is in fresh water? How does the formula work for that?
Because you have to account for the relative densities in wind buoyancy.
Oh, relative density.
Yes.
Ah, thank you. You mean if we look up what specific gravity means, we'll say relative density. That's exactly right. Thank you very
No,
much. The
I
debate is
really
finished.
don't think that
You've
you're
just
wrapping your
explained
head around
relative
what's
density
happening here,
explains
Ross. Look,
everything.
relative density is not something that just you can just throw away and ignore entirely. Okay, it's
I
just
didn't.
simply
I'm
not the
saying it
cause
is
of
the thing.
gravity. Yeah, hey, Ross, come on, man. It's just something that is not the cause of gravity. It's not like you can just ignore it. In order to calculate the actual dynamics for how objects move, especially when you're talking about buoyancies and in mediums, you do have to account for these things. But that's not where you're getting the direction and acceleration of motion from alone. You have to use gravity in order to get the right value. And this is high school level physics. I mean, he should know this.
Okay, so then why does a feather fall at the same rate as a bowling ball inside of a vacuum?
Because they're both in the Earth's gravitational field, which is warping and curving the space around them. So they both will be experiencing the same curvature of space-time, aka the same gravity. So they will have the same acceleration downward.
And
Because
yet, if we
it's
drop them,
space-time around them that's being affected.
and yet if we drop them in the medium of air, they fall at different rates.
Because of air resistance. I mean, come
Uh,
on, that's so obvious.
so resistance is a force.
Yeah, no, duh. You obviously have air resistance that's slowing you down and changing your acceleration. Nobody's going to argue against that.
Gotcha. Well, see, my argument is that resistance is the force, the only force.
Well, it's
Attraction
wrong
is not
then.
necessary. Attraction is not necessary. It's not required. All that is required is a force of resistance to prevent something from falling, that something will fall indefinitely until a force of resistance prevents it from dropping.
So
And
then
that
how do you
space
explain the
happens to
actual
be the physical
measured
plane
force
at
of
the bottom of the known
attraction?
universe. Thank
So,
you. I was nearly finished my sentence.
so then how do you explain the actual measurement of a force of attraction in
There is
Newton between
no,
masses in the Cavendish experiment?
All right, let's give Ross some
there
space to
is
answer there.
no force of attraction, is all I'm saying. There's a force of resistance. There's no force of attraction, apart from things like magnetic and electrostatics and so forth. But there's no necessary force of attraction in order to have our universal and observable up and down, which is all described by relative density.
Well, so then how do you explain? I showed you the experiment. You're like, I literally just showed it to you where it was showing you just for your eyes the measurement of an attractive force. Are you just going to look at the evidence as I'm presenting it to you and just say, nuh-uh, it doesn't exist? I don't see anything, even though when your eyes are showing you?
Pretty much, yeah.
Wow. Okay, so then it's just sticking your head in the sand and denying reality.
No, not really. So are you going to address any of the things that I brought up in my introduction now, since we've pretty much worked all yours to death? And
We
are you going
literally,
to
okay, Ross,
no,
this
and
is
are you
so
going to explain?
aggravating
No,
because
no,
we
no, come
haven't
on.
actually talked about what I brought up in my presentation. I talked about
It's
gravitational
been all
redshift.
you. It's been all you, mate.
Ross, I brought up gravitational redshift, which we haven't talked about. We barely talked about LIGO. We've spent this whole time talking about stuff you wanted to talk about, like relative densities. That was your presentation.
All right. Let's be fair then. If that's how you feel, I'll give you the ball, Grayson, to move us into something you brought up in your intro, and we'll try to unpack that. All right.
Okay. So I would like an explanation for gravitational redshift from Ross, where you actually have a difference in the passage of time based on your height from the ground. Like the lower you are, like time is passing differently for you. And you can measure this you can predict, you can use GR to predict exactly how many microseconds of a difference it should be, and it comes out exactly as predicted. How do you explain that, Ross, in your relative density model?
To be honest, I've got absolutely no idea what you're talking about. Sounds like absolute pseudoscience to me. And it sounds like something that you make up to try and obscure the fact that if the more you can obscure something and make it look like it's not understandable to the average person, the more you can get away with looking clever without actually ever saying.
All right,
anything.
we're doing some meta discussion here. So, Grayson, if you want to take like 15 seconds and explain right quick how this ties into our debate topic tonight, and then we'll give Ross a chance to respond.
Okay, well, I felt that was entirely obvious how this ties into our debate topic. It's a direct measurement of gravity using a prediction from general relativity, measuring the curvature of space-time, which you are literally measuring in the time dilation effects at a sub-millimeter level. It's not my fault that Ross doesn't understand what was done in this experiment or is not familiar with them. All he's offered so far in response is his own personal incredulity and just saying,
all right, we're back to the meta. All right, let's give it over to Ross to respond, and then Ross, if you want to move into something you brought up in your intro, feel free.
Well, actually, this does segue into something I'm talking about because he's mentioning the theory of relativity, and this theory of relativity was absolutely brought into existence to explain why we can't detect any motion of the Earth. Now, I'd like to know why, with the motion of the Earth being 1/3 times the speed of sound, just on its axis, as we're hurtling about 10 times faster than a railgun projectile in our orbital speed, our second slowest speed, is how does objects falling downwards, 9.8 meters per second squared, going so many times further fast sideways in order to create the illusion of falling straight down? How do you explain that just using gravity? Like, it's actually projecting things forwards and backwards at different speeds relative to every position on the Earth. Every single one must be unique. How does gravity, force of attraction of bigotry, explain that, especially when something is in front of our orbital speed, would mean it's actually being repelled away from the Earth as the Earth is racing into it to create the illusion it's dropping at exactly the same rate as something on the back side of the Earth, go in the opposite direction, as I explained when I used my diagram.
Yeah, I think that it's just fundamentally you not understanding the conservation of momentum.
Obviously.
No, like it is kind of obvious, at least from what I'm understanding of what you're like. I'm trying to wrap my head around what your issue even is. It seems like you just don't understand that when things move, everything on the Earth is moving like together. So it all starts out having that same starting point of initial momentum. So the forces that are different are what's going to cause the differential movements, and it's going to be attracted to the center of gravity of Earth. So I don't understand what you're not understanding about that.
Okay, well, let's just use an aeroplane as an example. This was actually a debate I was going to be doing with somebody else today, but I don't know what happened to the guy. It's a pilot. I was going to bring up the fact that if you took off with the momentum of the Earth towards the east, so you take off from the east, you're already going 1,000 miles per hour, you add 500 miles per hour, just rounded figure. So you're going 1,500 miles per hour. Now, if you turned around and did a 180 and started traveling west, that would now mean that you're traveling backwards 1,000 miles per hour as you're going forwards 500 miles per hour. So you're actually going backwards at some total of 500 miles per hour in order to create the illusion you're going forwards 500 miles per hour. That's ridiculous. Now, Occam's razor.
You would just be going 500 miles an hour in the reverse direction. So what are you talking about? Like, if
what's that?
I understand. I literally. So what you're saying, the plane initially takes off and it's going in the same direction of Earth's movement, right?
Yeah, 1,500 miles an hour.
So if it initially had, you said what, 1,000 miles per hour is your initial, and then it's moving at 500 miles an hour to the east, right? That was your start, right?
Yeah. Some total of 1,500.
At that point, the plane is moving 500 miles an hour to the east. Okay.
1,500.
No, 500. It's starting at 500 because
it's starting at 1,000.
Because the ground and the plane were both moving at 1,000 feet per second, and now they're still moving at 1,000 feet per second. And the plane is now moving 500 on top of that. So relative to the ground, the plane is moving at 500 miles per hour.
Yeah, but its real speed would have to be 1,500 miles per hour.
There's no such thing as real speed. Speed is absolute. So its speed relative to the ground is 500. So now what's your problem with the plane going in the other direction?
So this is the problem, is you have to deny reality and say that speed isn't real.
No, speed is relative. That's just a fact.
Well, not really.
It is a fact.
If you
I'm sorry, Ross, but that's just it's a basic fact, like elementary school.
All right, fact. Then. Well, let's try another example. Maybe this will be a bit easier for you. As a skydiver jumps from a plane.
Yep.
Are you going to say that he's going to continue to retain the inertial speed of the plane as he jumps from it? And so
no, because there's going to be wind resistance.
So there's wind resistance. So
The
wind
wind resistance
affects,
slows him down, yes.
but the wind resistance of the Earth is still keeping him going 1,000 miles per hour he took off with in the first
The
place.
wind is rotating with the Earth, Ross.
But how can we have winds going all different directions, different speeds, different heights?
But because there's differences in pressure that cause wind, like internally.
Yeah.
Overall, the atmosphere is rotating with the Earth.
That's nonsense. We couldn't have
It's
winds
not
if that's
nonsense.
the
That's
case.
a fact.
We couldn't have winds if that is the case.
That's not true. You
We've
have
got things
differences.
like
You have differences in pressure that are caused by the sun differentially heating parts of the Earth as it rotates.
Or could be just the sun moving around above us that's causing that as well?
Nope.
Yes, that works equally as well. In fact, it's far more sensible because if we consider a tropical storm, for example, a cyclone, winds that reach a speed of, say, 175 miles per hour are absolutely destructive. They will destroy villages, forests, plantations, totally wipe things out. And yet perfectly still air is going 1,000 miles per hour. So this wind is going barely a fifth the speed of perfectly still air. And
I just don't think that you're understanding what relative speeds are. Like the speed.
Obviously not, because I only believe in real speeds.
There's no such thing as real speed relative to what? What's your reference point, Ross?
Well, the ground.
But if the ground is moving, then there's no such, it's all relative.
Yeah, but the ground isn't moving. We've got no method of detection. You cannot demonstrate that it is moving.
Yes, we can.
No, you cannot. You haven't, never have.
We can use a ring laser gyroscope. We can show that it's moving. You know, we can show
that exactly talks about
look at observations. You can look at observations in the sky that show that the Earth is revolving around the sun.
That just shows that those things are moving. As you said, it's all relative. From the point of view of the Earth, that's perfectly still.
This argument that you're making right here is basically just that. Well, listen. Okay, you could say that that I drove my car 60 miles per hour down my street, or you could just say that the entire universe moved at 60 miles per hour around my car that stood still. And
exactly, and which is the most sensible argument.
Technically, those are mathematically and physically equivalent situations, but everybody would laugh at you and call you silly if you tried to say one versus the other. And that's Ross's entire strategy right now.
That's your strategy, because you're saying that's exactly what it is doing. Whereas I'm trying to say, when I finally finished saying this point about the storm, is that the storm is actually rotating in a circular fashion, whether it's be anti-clockwise or clockwise, depending on which side of the equator it is on. How is that possible then, that the entire thing is drifting 5 times faster with the speed of the Earth? Plus then also, let's not ignore the orbital speed, which is a massive, massive speed that you say this is also going. I guess you're just going to hand-wave dismiss this as relative as well. But let's just
obviously assume, that's the fact.
Let's just assume we'll ignore the orbital speed for now. We're just going to deal with the rotational speed on its axis, of 1,000 miles per hour. These 200 mile per hour winds are causing utter destruction, and yet they're moving in a circular pattern, going the same speed around the epicenter of the storm, and yet it's also drifting sideways with this impossible
what's it doing relative to the ground, Ross?
Of the ground.
What's it doing relative to the ground?
What it's doing relative to the ground is spinning on the spot and moving whichever direction the forces dictate it wants to go.
Yep. And it's not an issue.
So the rotation of the Earth.
The ground is moving. Wait. Okay, you talked about. I want to illustrate the difference, because you said that's what I'm doing with the car moving versus the rest of the universe moving. But really, you're the one saying that it's not the rest of the universe that's moving. It's not the sun or the galaxies that are moving.
I'm not talking about the universe.
Really, what's happening?
I'm talking about the storm and the Earth.
Come on! Don't interrupt me.
Hold on. One second, Ross. One second. I don't want to put you on mute. Just give Grayson a second here. Just hold your thought.
I'm just liking to keep it relevant to the argument.
All right, don't interrupt me. Like I said, just give him a space, and you absolutely will have some time to respond.
You're saying it's not relevant, but you were the one who told me that I am the one in my analogy saying that the rest of the universe is moving around my car and my car is actually standing still. I'm only illustrating the analogy here. The car is the Earth. You're saying the Earth is standing still and the rest of the universe is moving around the stationary Earth. But in reality, that's you saying your car is standing still and the rest of the universe is moving at 60 miles per hour around your car. That's the analogy. That's why you're doing it and not me. I just wanted to make that point clear.
No, we're talking about a storm here now. Yeah, try and stick to the topic. I'm talking about a storm rotating at maximum speeds of 200 miles per hour around an epicenter, which would mean that part of that storm is actually only moving about 800 miles per hour because of the spin of the Earth beneath it. The other side of the Earth, other side of the storm is moving 1,200 miles per hour, and yet all of the winds relative to the Earth are only moving 200 miles per hour each, as though the Earth is standing
Relative to the
perfectly
Earth.
still.
Perfect. You just explained it.
All right.
As though the Earth is
Hold
standing
on.
perfectly
Let him
still.
finish, to be fair.
Yeah, so how is it that winds can be moving, 5 times slower than perfectly still air and cause such huge destructive forces?
Because they're moving at a speed relative to the Earth, and their destructive force is a function of their speed, the wind speed relative to the Earth, and the things that the wind is actually coming into contact with and hitting, like houses and trees. That is the number that is determinative of how much damage is being done, is the relative wind speed relative to the stuff it's hitting. That's what's important, okay? The relative speeds. Everybody should be able to understand this. It's very intuitive and straightforward.
It's completely non-intuitive whatsoever. Because as we know, if we take anything, like we said with the skydiver jumping from the plane, what happens to him is wind resistance. When we take anything of the Earth and throw it through the air, it suffers wind resistance. The Earth itself is of the Earth, so it should be moving through the Earth and suffering this wind resistance. So the perfectly still air, let me finish, mate, before you have your little girly little hissy fit. Is it?
Oh man, that was crazy.
All right, 1 second there, Grayson. Let's let him finish his thought.
He never
the
finished
Earth itself would be moving through the Earth, through the air, through the atmosphere, as though the air is perfectly still, in which case we would always be facing 1,000-mile-per-hour headwind racing through us, and would be charging through it so fast at the speed of 10 times faster than a railgun projectile that would be leaving it behind us in a huge comet tail. It would be absolutely impossible. And these speeds are an absolute necessity for your spinning spaceball to even be possible in the first place. It's all mathematical garb. When we start to understand that the Earth itself is stationary, fixed at the bottom of the universe, then the wind doing as the wind does makes perfect sense. It is all logical and intuitive. Your whole idea is absolute nonsense. Every last bit of it.
Okay, are you done, Ross? You finally
I'm
done?
Jason.
Okay.
Yes. So
you literally said that the Earth is having wind resistance as it moves. The Earth is going through wind? Like it's a ball that you're throwing on a windy day and the Earth is just getting hit by winds as it moves through space? Like you think that there's an atmosphere in space, there's wind in space that the Earth is moving through? This is ludicrous.
No, I'm just saying that if there is an atmosphere around the Earth and the Earth itself being of the Earth, as everything is, then there's no reason why it would drag the atmosphere with it. I've already used that example with my vacuum chamber experiment to show that gravity does not hold gases down whatsoever.
Yes, it does.
Gases are free to roam as they will and will fill the entire container surrounding them, given the available temp.
Let's address that because you did bring it up in your opening. So first of all, completely incorrect. Whenever you have an actual like a canister or the atmosphere itself, as you go up in height, in elevation, the density of the air goes down, and everybody can agree with this. It's a basic fact.
So density. Okay, cool.
Yes, and so as you go higher and higher and higher, the density of the air gets less and less and less and less and less as it asymptotically approaches zero. So you never have the situation like you falsely painted at the beginning of your opening, where you said that in the atmosphere, you have a point of high pressure and a point of low pressure. And for some reason, they're just not mixing, even though that's physically what would happen, because you have a gradient. And you can measure this gradient. Right now, everyone at home can measure the gradient in the atmosphere. You can literally like get a barometer app on your phone, measure the density of atmosphere at the bottom of your room and at the top, and you can measure a difference. It's less dense the higher you go.
Yeah, are you kidding me?
That's a fact.
That's a fact?
Yes, you can measure it yourself.
In a room?
Yep.
I thought you said get a room. I was going to say with the theory, what's going on here? I want to just inject right quick.
It's easily measurable. I mean, I would highly encourage everybody, like, get a barometer app on your phone. An iPhone has a barometer built into it. You can measure it can measure pressure differences, and you can measure the pressure at the bottom of your room and at the top, and you'll see that there's a slightly less amount of pressure at the top of your room.
Well, I was just trying to inject before you reiterated. I put a poll up earlier. So is gravity a hoax? 24% has voted yes, 68% voted no, and then 7% said gravity backwards is my orc name. How many of you did I get to say Yitavarg? Anyway, go ahead and continue on. But that's our poll right now. So 24 to 68. And then we got our joke answer. So, yeah, that's hopefully helps reset the tone. But go ahead there, Ross. I'll give you a chance to respond.
Right, cheers. So we could use a similar example in a swimming pool, how the bottom of the pool has a greater pressure gradient, has a greater pressure, but that's simply due to the volume of the water above you pressing down upon you. And as you get higher and higher
Gravity.
towards the surface, it decreases. No, it's just because of the density of the
That's
water
gravity.
itself. Yeah, it's gravity. No. It's just the volume of the water and the density of the water that creates that gradient. And
Why
when
is
you
it
reach the
pressing down on
surface,
you, Ross? You said that the
because of the
volume of
volume
water
of
is
the
pressing
water and
down.
the
Why is it
density.
pressing down?
Because of the volume of the water and the density. Now, if you're done interrupting, I will finish my
I'm
point.
not done interrupting. Why down?
Because of the weight of water. It has density and weight, and then the volume of it determines how much pressure it is putting upon you. Yes, that
Why
is
is the
what
weight
physics
down?
is all about.
Why down?
Because it's physical and everything needs a base to
Up
be
is
built
physical
upon.
too. Left and right are physical. Why down?
Because that's the way it works.
Oh, because that's just the way it is. Because you don't know how to explain it, even though gravity
I
explains it
explained it
perfectly
to you.
well.
I explained it to you with acoustics, how we have higher notes and lower notes are more bass. In physics, we need a base. Everything depends upon a base. You can't build a house without a base. The base is the bottom. The earth is the bottom of the universe. That's how physics works.
Bro, you're
Get
just
used to
doing.
it.
You're literally just
So
doing
now, hey,
consciousness.
no, I'll give you a chance in a
You're literally
second,
just doing
Grayson.
word
I'll give
association
you
right
a
now.
chance in a second, Grayson. I'm still making my point
All
because
right.
we're going back to the atmosphere now. And
Let's
while we have
let's
a pressure
let's take
gradient
10
in air,
seconds. All right, just to be fair, Ross, let's take 10 seconds to wrap this up and we'll hand it back to Grayson
I'm
to bounce the
trying
idea.
to.
Okay, sorry,
I'm
Ross.
trying to. I'm nearly there. And it's the same sort of thing happens in the medium of air. We have a pressure gradient due to the volume of air above us. It's a finite amount of air, so the higher we go, the less air there is on you, so therefore less pressure.
Okay, so this was the exact point that I was making in my introduction, where ultimately the flat earthers don't have an explanation for why gravity is downward. They just have to assume the direction is down and beg the question to start with. And when I asked Ross why, he started doing stream of consciousness word associations of saying, well, look, base over here it sounds the same as this word base, even though they have two different definitions in different contexts. Because they're homophones, I'm just going to say that they both mean the same thing, and it's some sort of cosmic pattern that the base requires the base, and that's why down. It's literally just meaningless gobbledygook. It's just word association from somebody that doesn't know the science.
There's no such thing as coincidence. There's a reason why these words have the same thing. It's the reason why the word compass also means the instrument used to draw a circle, or also the same instrument that magnetically points towards the center of the circle. It's how we draw our maps in the first place, why the sun is all encompassing. We use words for a very specific reason, even if we've lost the current usage, the origins, where they came from us in epistemology. Basically, there's no such thing as coincidence. The base is the requirement for how we have everything. There is a universal up and a universal down, and everything finds its place according to relative density. You don't have to ask why down when it just is. A child understands intuitively the moment it drops something. It's not going to drop up. It's not going to drop sideways. It always drops down. This is just nature. It's the very nature of existence. The very first law of physics is to make the observation, not to start making up nonsense. Why not? Why doesn't it go this way? It doesn't go that way because it's just the law of physics. Everything has a universal downward tendency unless it's lighter than air.
So here's the thing, is that in science, we do have an explanation for why things fall down. It's because they're falling towards the mass of the Earth. That's what causes the direction. So it's not like we just have to say, well, look, okay, science is descriptive. Wait, don't interrupt me, Ross. Okay, come on. We don't have to just say, oh, well, science is descriptive and that's just the way it is. It just is down because that's why. Don't ask anything further. Don't ask any questions about why down. That would be problematic because the flat earthers can't answer that. So you just have to say, look, it just is the way it is. We have no explanation for why, even though the other science with gravity can perfectly explain why very, very easily. It offers that explanatory power. But the alternatives, the relative density, the electromagnetic gravity, like none of these stuff can explain why the direction is downward. And that is why they cannot explain gravity, and why their explanation for gravity utterly fails, and why gravity follows general relativity. We know it quite well. We can make the predictions and they can't.
Well, your explanation is nothing more than an assumption, an unproven assumption, which has been proven wrong by the Tamarack Mine mysteries and similar. And so anything that is, the that Occam's razor says, that anything using assumptions can be dismissed, where the more simple explanation is easily explains it as due to relative density. Is that if the medium is insufficiently dense to give resistance to it, then the thing will sink. If it's sufficient to give resistance to it, it will float. And if the thing itself is lighter than the medium, it will rise upwards, like the basketball at the bottom of the swimming pool.
I got a question for you then. Why is it you're saying that, look, if the thing beneath it is sufficiently dense to support it, then it won't fall. And if it's not, then it will go through. So why does it matter the thing beneath it? Why doesn't it matter how dense the thing above it is? If the thing above it is less dense, why doesn't it just fall up?
Because the less dense thing does not give resistant force to give it buoyancy.
But why not?
Because of the lack of resistance from its density.
Wait. So the thing doesn't provide resistance because of the lack of resistance? Circular a bit much? That's circular reasoning, Ross.
Well, it's not. It's pretty obvious.
You're saying that it's important, the density of the thing below the object, because it can offer resistance because it's beneath it. But why can't the thing above it offer resistance or support? Why does the support or resistance only matter if it's below it and not above it or to the left and right? Because it's about relative density, right?
Yeah, because it lacks the density. Because everything has already organized itself according to density, and it organized itself from the bottom up.
Okay, let's we have a circular ball, right? And we have equal density in every single direction. The medium is equally dense in every direction for 50 miles. Which way is the object going to move?
Say again, what?
If you have an object, right, like a lead ball, and it's surrounded by a medium that's equal density in every single direction for like a long time, which direction is it going to move?
Are you talking about air?
It doesn't matter what the medium is. It could be air, it could be water, it could be oil, whatever.
Well, if a medium is mercury, it's just going to float.
It depends on the relative densities. Okay, this is a very heavy lead ball, but it doesn't matter whatever medium you want, dude. Like, we could do water, we could do air.
So not mercury?
It doesn't matter. Just pick a medium.
Well, if I say mercury, I'll say it's going to float.
A lead ball floats in mercury?
Well, an iron one will. A lead one will probably assimilate.
Okay, I don't care what the medium is, man. Accept the situation and ask me if it's a uniform density in all direction, and it's the density differences that determine the motion that'll have. And let's just say the medium is air. You have a lead ball that's introduced. What direction is it going to go?
It will go down.
And why will it go down when the density was the same in every direction?
Because air offers no resistance factor, and air is obviously already sitting on some sort of surface that has a resistance factor that's given buoyancy to the air, and it will go down towards that surface. Same as it will in water, but it won't go as fast because water gives more resistance because it's more dense than air.
So if we had this experiment, right, and you were looking at it at a camera, and we like rotated the camera so you no longer know which way is down and which way is up, and you just have this lead ball, and it's going to get let go of, and you have to predict which direction it's going to move in, and you can do any kind of density measurements you want, but it's a room that is equal in every direction. It's a cube shaped room. You don't know which way's up, which way's down. How do you determine which way it's going to move?
Well, obviously, because I know we're not in outer space, because the universe has a base, and that is the plane.
But how do you determine what direction that is? If you're saying that it's
the bottom of the known universe, it's always down.
But how do you know where down is if you're in this room, or you're not in this room? The camera's in this room, and you don't know. You can control this camera, and you have to determine which way this thing is going to move when it's let go of. How do you know? It will
tell you which way down is. It will tell you by its own actions because it's more dense than the air.
You need to predict it, Ross. This is science. You have to make a prediction based on your model.
I did downwards.
But you don't know which direction that is. Tell me, you're supposed to predict. I need you to predict. Before the ball moves, you need to predict which direction it's going to move, which direction will be down. And we could predict using gravity.
You don't need to make these predictions for your silly hypothetical games, right? These are your silly hypothetical games.
He's talking over the end of my question here. You always get on to me for interrupting him, but
all right. If that does sound fair. So
I wanted to get out the end of my question. I just wanted to ask, if we are using our scientific models to do science and make a prediction, so before this ball is released, I can use my model to make a prediction for which direction it will move and which direction down is based on where the majority of the Earth's mass is relative to this ball. But you need to make a prediction based on the relative densities. And the way we've set up this experiment, it's a equal density in every direction. It's completely symmetrical. You cannot use density differences to make a prediction.
How do you know where the Earth is in this instance?
You would have to have that information. I don't know. You'd have to either you could do that with like a radar, you could bounce something off of it and determine like through seismology where the Earth is. You'd have to figure out which direction the Earth's mass was relative to the room. I would admit that.
So here in reality, we don't need to do all that stuff. We already know that the Earth is going to be downwards. If we're up above the surface of the Earth, it'll always be down.
Question.
No, I'm not. It's a known thing.
If
you know something, you don't have to guess. You don't have to predict.
Here's the thing, though, is that I'm asking you to predict or to explain why things go down, and you're already just begging the question that they already do. You're not giving an explanation for why.
That's right. I shouldn't have to. I don't need to invent anything new that's already been observed since the beginning of time.
It's called a begging the question fallacy, Iron Horse, and it is a logical fallacy. And by the way, so is the etymological fallacy that you were using earlier about using a word's origin in order to like infer about its meaning. Like those are both logical fallacies that you're using.
Absolutely not. It's the very reason we have the word gravity is because it comes from the word gravitas, which actually means weight. It does not mean attraction and force due to biggity. It doesn't mean bending and warping of space-time. It just simply means weight. And anything that has weight is a weight determined compared to something else. You know, the weight of something in water is less than the same thing as the weight of it in air. So it's all relative density.
But again, you cannot explain why the weight is pushing down instead of up to the left or right.
Yes, I can, because of its density relative to its medium. That's all that matters.
We already said, if the density is equal in all directions relative to the medium, you still have a weight, but your model cannot explain why.
It can, because it's the weight of the object relative to the medium. The medium is insufficient to give it buoyancy. It's not going to give it buoyancy at all in any direction.
Okay,
it's just going to drop into a plate.
You need to understand this. The relationship with the density is equal up, down, left, right, every direction. You have the same density relationship. You can't tell just from looking at the densities what direction is down, but it's still the weight goes down for some reason, and it cannot be because of the density, because that's equal in every direction.
Well, if you're standing on your head, it's dropping up, you know. So it's
this again is getting absurd, man. You're not having serious responses.
No, your terms are completely relative, aren't they? You know,
you're can call it whatever you want. Responses anymore. You're just
you can call it because your questions are no longer sensible. They're meaningless.
It's very sensible. It actually is the crux of your entire model.
Everything in physics behaves in accordance with the universal up and down function, which is determined by relative density.
There's no universal up or down function. You're making that up.
No, you're the one that says there is no universal up and down because you want to believe in your fantasy ball so hard that you have to have this force of gravitational attraction so that things on the bottom can cling to it as you hurtle through a vacuum of space.
Harder.
Whereas we don't need, if we remove all assumptions and you know nothing to start with, and then you start making observations in nature, then you will see that if you hold a rock and you let go of a rock, you've removed the force of resistance that your hand has given it, but the force you've applied to it by lifting it up has an equal and opposite reaction, and it will fall back to the place of rest from where you picked it from.
You're debating a straw man because nobody's debating that. I mean,
well, we are, because you're saying, why doesn't it go upwards or sideways? You're the one asking that question. So you tell me why it doesn't.
All right.
I already have.
You already have
because it's more dense than the air.
All right.
You assume
it seems to me, guys, just 1 second. Like I said, I don't want to put either of you on mute. You've been doing great. But it seems like we may need to move into some new territory. We will go into Q&A, and we'll let our speakers have a little break and let them have, a bathroom break and get some refreshments at that time. So get your questions in. We will move to that Q&A shortly. Hit the like button. I've given you no option, as you can see in the poll. But let's try to push into some new territory, I think, there, fellas, because I think the audience is understanding where you may disagree on this one, and the nuances that you have in that disagreement. So if you have something that has not gotten hashed out, let's try to hit that.
Yeah, I
Well,
agree that.
did not have an explanation for any of the evidence I offered, from gravitational redshift, gravitational waves that were measured by LIGO. No explanation for any of these things. Like, all these things necessitate that space-time is curved, and that's what causes gravity. Like, these are the evidence to support that. He said, I just assumed that gravity is space-time, but this is the evidence. It's not just an assumption. It's backed up using the scientific method.
Yeah, well, I call that all absolute complete pseudoscience. The idea that we could detect a gravitational wave from thousands and millions of light years away is
Yep.
absolutely ludicrous.
Why?
Light itself exists instantaneously. It is the fluorescence of the noble gases in our atmosphere that give us our light, that occur instantaneously. Light does not travel. So the whole idea that these lights are traveling from outer space is just absolute ridiculous nonsense that you guys have to make up. You've been supporting this lie since like 1543, when Copernicus first put the ball spinning around the sun.
Okay,
You've made up,
we got it. We got it.
you know, it's a little old lady who swallows a fly. You've made up lie after lie after lie
You
until
made your
eventually
point,
you've swallowed
Iron.
a horse and the whole spinning space ball is dead, of course.
Okay. You made your point. Okay. So, but in reality, okay, these are not just things that we have assumed. We've used the models to generate a testable prediction. We test the prediction and it's like incredibly accurate. Like, you can, I mean, contrary to what Iron Horse believes, like, these experiments have been done at every level in the atmosphere. They've been done in satellites. They've been done in James Webb Space Telescope. They've been done outside of Earth's atmosphere. I know he doesn't believe that because he doesn't believe anybody's been outside of Earth's atmosphere, but that's a problem for beyond this debate. The point is, we have the actual data, the measurements. We can exclude other explanations like relative density for the reasons I've already outlined, that you're literally just, it's begging the question. It's a logical fallacy. You're assuming your conclusion before you even start, that there's a downward acceleration. You can't start with the downward acceleration. You have to explain the downward acceleration.
No. I'll just say that we allow a downward acceleration because of the lack of resistance of the medium of air. It's not sufficient enough to resist a thing of mass from accelerating through it until reaching a point of terminal velocity, whereas the ground itself ceases it from dropping any further because it's dense enough to resist it. We don't need anything further than that.
It seems like we're really hitting a wall on this one, honestly, guys. So it might be a good idea, like I say, to move into that Q&A shortly and let our speakers have a break. But once again, if there's anything that we might want to move into, because it seems like a lot of these subjects we're just kind of reiterating. So,
well, I mean, yeah, we could demonstrate that light actually does travel and is not instantaneous, but then Ross would just deny that those experiments exist, or he would say that they're a hoax or that it's a conspiracy. So as we wrap up, I would just like to say, because I mean, any evidence that I bring forward that is tested, peer reviewed, like hundreds of scientists collaborations, like way too big to fake, Ross is going to say that it's a hoax, it's a conspiracy. So I want to know who is doing this hoax, who's doing this gravity hoax, because we have scientists on every country on Earth doing research in the physics of gravity. And if it was a hoax, at least one of them somewhere would have figured it out if they're not in on it. So is every scientist in on this? Who is doing this hoax, Ross? Because there's countries that are geopolitical enemies that all agree that gravity is real, even though it would be in their geopolitical advantage for, like, China, if they figured out that the US had been lying about gravity this whole time, they would point it out and say, here, look, we've dedicated our resources, we've got the scientific equipment to prove that the US has been lying about gravity. And then suddenly, now the rest of the world shifts towards a more China trusting geopolitical order, and they win. So why aren't they doing that? Why are all the countries on Earth in agreement that gravity exists?
Well, thank you for your summary there. And I'm sure you didn't mean to introduce another topic to it because we're just doing a summary. So I will ignore your questions.
Honestly, I don't mind if you guys want to launch into that discussion.
Yeah,
like
just
I said,
the last.
we don't
I wasn't
have
doing a
to.
summary.
We don't have to
just
stop.
at the last topic. Last topic.
Okay, well, I would actually like to address the one you were bringing up just prior to that, since I thought you were doing a summary and I was going to address it real quickly, is when you brought up the fact of satellites. You're saying things don't go above the atmosphere, whereas I don't deny that whatsoever. I think our atmosphere reaches 12 to 14 miles high. That's where the atmospheric gases cease fluorescing, so anything that goes higher than 12 to 14 miles has reached outer space. It reaches up to about 70 miles high. And so, of course, we can have satellites in that above the stationary plane of Earth, which work according to the maglev type gravitational or anti-gravitational forces. The maglev thing works quite well. A satellite would be absolutely impossible on your spinning space ball because, again, the orbital speed of something equivalent to Mach 88, even though we don't measure Mach outside of the atmosphere, even though it's equivalent to Mach 88, as again, if we go back to my diagram, which I showed earlier, showing how one side of the Earth going that direction with the orbital speed would be going away from the Earth, whereas the things going behind it are going that way, things going that way and that way, whatever. They're all over the shop. Satellites would be absolutely impossible on the spinning spaceball model. However, if we have things like the Satelloons or maglev devices in our atmosphere, they can absolutely work. And so satellites aren't entirely impossible on the flat Earth, and they
All right, we got to pass the ball
actually make far
here.
more sense than the spinning space ball.
So I just want to say real quick that speed is relative. You don't feel absolute speed. You feel changes in momentum. So that explains everything that Ross just said. Momentum is conserved. So this is a basic introductory level physics concepts. Go to your local high school physics teacher and they can explain this to you if you're still confused about it, Ross. But I really want you to address what I asked you about who is doing this hoax of gravity in your review.
Well, it's just something that everybody's agreed upon because they've all been convinced that we live on a spinning space ball, and so they haven't really given themselves the opportunity to question it or doubt it. Whereas the flat earthers are the ones who are doing all the questioning and stuff. And because we don't make a career of it, obviously we're considered, on the fringe of science. We're not really taken seriously in most cases. So it's the flat earthers who are the ones who are doing all the questioning of things. It's not China, it's not Russia, it's not America. They're just going along with it because they're making a huge hoax out of humanity and making billions of dollars out of it doing so.
Okay, so I'd like to show that the papers that were testing this that I've shown you tonight were both from the last 10 years. So you're saying that nobody's testing this. They all just assume that it's true because that's what they've been told. But the scientists are testing this. They built LIGO to test this and see if they could, in fact, detect gravitational waves, which they did. It was a confirmed prediction that they tested. So they are testing this. That Cavendish experiment that I showed you was from 2022. They are currently testing these things. This is not flat earthers. These are actual scientists testing general relativity to see if its predictions are accurate. I've worked together with scientists who specialize in general relativity testing. I took cosmology courses from somebody that actually does test general relativity as a living. He's paid to try to poke holes in general relativity and try to find areas where general relativity fails. He's getting his paycheck to try to debunk general relativity. That's what he does for a living. He does tests to see if it works. People are doing this. So it's just a lie to say that nobody's doing this and they just assume that it's true and that the only people researching this and testing it are flat earthers. That's just a lie.
Okay, so to tie a bit of a bow on that then is to say that there is such a thing as confirmation bias. And there is also such a thing as what they call, what we observed with the double slit experiment, is how things observed completely differently when you're observing them to how when they're not observed. So there's quite often the fact that it's actually the observer himself and their expectations which actually create the results that they are seeking. That's an undeniable fact, and it's the next stage in science which we need to try and overrule. So if you go in with a completely open mind without any sort of expectations, you might find something completely different, which again ties all the way back to Eratosthenes, whereas if he had have set out with the confirmation bias that he's out to prove a stationary Earth with a local sun, he would have proven exactly that. So It's all about what you've preconceived in your mind. You're going to find results to match that.
Okay, Ross, final question. So is it all just confirmation bias? And it's just our own biases as observers that are explaining why? When LIGO was able to make a detection, they were able to say, look, we detected a gravitational wave signal that is corresponding to exactly the waveform that we would expect for a neutron star collision. And we detected this at this exact quadrant of the night sky. Now they send out they send out a message to all the local observatories on Earth and say, could you guys look at this spot of sky and tell us, did you observe a gamma ray burst of light coming from this region of the sky 1.7 seconds after our observation? And they found it. Is that just a confirmation bias? They predicted exactly what they should find, and then they found it exactly that. And it's not like you could just say, look, I'm going to find a gamma ray burst right here, and then there's going to be a gamma ray burst right there. Is that just a coincidence? Is that confirmation bias? How do you explain that?
Well, I don't know enough about it personally, but I can say then that if gravity exists universally everywhere, why would we have to look at one particular spot in the universe in order to see it when it should be everywhere observable all around us? And so this LIGO should be able to detect it everywhere,
Yes.
all the time, not just in one
So-
specific little part in outer space due to some gamma rays. You know?
It can actually. What you're referring to is called the gravitational wave background, and it's a constant hum of gravitational waves that are detectable in every direction. It's analogous to the cosmic microwave background. And we can and have detected the gravitational wave background like you're talking about. That's just a hum from everywhere. The difference between that and what I'm talking about with this specific observation is the wavelength of the gravitational waves. The wavelengths for gravitational waves in the background are just really long wavelength. This one, though, is exactly characteristic. It has an exact waveform that is characteristic of a rare event in the universe. That's why we could only find in this particular spot, because it's from a neutron star collision, which is pretty rare. It doesn't happen very often. And it causes a gamma ray burst and a burst of gravitational waves. And we've seen that happen, thus verifying beyond any shadow of doubt that gravity is real and exists.
Sorry, you just said we've seen that. I have not seen that.
Humans have seen that, Ross. Would you rather I use
Well,
that?
so I have to take your word for it. This should be something I should be able to look up on, find a YouTube on, and see for myself. Can I do that?
I'll send you the paper. I will send you the paper.
The paper.
Yes.
No,
they published
this. Is a visual thing. This is a visual thing. I should be able to see the video of it and see a gravitational wave for myself.
Would you like to see the waveforms that they measured in their paper? I can show it to you.
I don't want to see waveforms that have been measured on paper. I want to see what they saw that you said we've all seen.
Oh, wait.
That's a paper.
Sorry, Ryan. I keep sharing the wrong paper here. I will show you, and we can just wrap up after I show you this one. Sorry about that. I'm trying to find.
I think you're just wasting our time because you don't have a video. You are not showing us the wave.
Just look up.
That's not a video.
This event. It's called GW170817. This is the observation where they had gravitational waves 1.7 seconds before the gamma rays from the same event. Here's the picture. Here is what the actual gravitational wave signals look like. This is at LIGO in Washington. This is at LIGO in Louisiana. You can see the actual gravitational wave form right there. That's the signal. It was identical in both, thus confirming this is an actual real signal, not just noise. This is what it looked like when it hit both of their detectors. And then we can look at here's a further breakdown showing the signal itself, the raw data right here. And you can see where in the sky it's coming from right here. But I know you don't like this because it's a sphere. But here's the region of the sky where the gravitational wave came from. And then it was later verified from an actual other observation of the gamma rays from a whole other observatory. Different owners, different operators, different funders, completely independent. So that's what you need to explain if you're saying gravity is not real. Here's the proof that it is.
I'm saying it's completely open to interpretation. If you want it to be that, that's what it will be for you. Simple as that.
Wow.
If you really want it, you'll find what you want.
Wow. So just a complete hand wave dismissal because of your own incredulity.
Well, it's exactly the same going back to Eratosthenes. If he wants it to be the circumference of a spinning ball, it's the circumference of, well, it's a stationary ball back then.
So
but
the
if you want it to be the circumference of that, that's what it is.
Existence.
If you want it to be the circumference of the equator, that's what it is. So this could be anything you want it to be.
So wait. You're saying that it's just because they wanted to see a gamma ray burst from a very particular place in the sky at an exact time point, that they just manifested it and they just saw that gamma ray burst. It's a coincidence. They just wanted to see it, so they did. That's all.
How could somebody else see it then if it's down the track later on?
Because they're permanently looking. These observatories are always looking at the sky. and they mark down when they get little hits. So they knew they recorded the gamma ray burst, and then LIGO called them, hey, wait, did you see a gamma ray burst from this exact quadrant at this exact time? And they say, yeah, actually we did. And they say, oh, that's exactly what we predicted you should see, because we saw something 2 seconds earlier.
God, so it could be absolutely anything.
No,
so,
it couldn't. It really could not be absolutely anything.
It could, because you don't even know.
Across the US, in Washington and Louisiana.
Is a physical thing.
You
don't have to keep talking again every time I start trying to respond. I said, you don't even know that the universe is a physical thing.
Oh, we can all be a brain in a vat, Iron Horse. It's all just solipsism all the way down.
That's quite entirely possible too.
Okay, so whenever you lose the argument, all of a sudden it's just, we don't know anything, and it could all be made up, and we could all just be dreaming. Who knows? And nothing could be real.
Well, until we actually go to another star or walk on another planet, then it's all just assumption.
You know, I've never been to Australia, so I'm just going to assume it's just assumption. I'm just assuming Australia exists. Who knows? You could. Well,
I think it's pretty obvious that if places are documented and we know people live on them and we've been there, then yes, we can confirm that it's true.
Well, I've never been to Australia. I mean, people have
never been to Mars.
Other galaxies.
Nobody's ever been to Mars. There's millions of people live in Australia.
Okay, now
millions of people live here. Well,
I'm just going to say all those people are a hoax, because that's your strategy with this. Any evidence to the contrary, it's just a hoax. They're just making it up. I can't say who or why, but it's just made up because it disagrees with me.
I'm not saying that anybody that's walked on Mars is lying about it, because nobody's ever walked on Mars, so nobody's lying about it. But many people have walked on Australia, so therefore I would assume they're not lying.
What about the people that walked on the moon?
Well, they've even admitted that it was animation. It was a hoax. They've never been there.
That's a lie.
That's exactly what Buzz Aldrin said, that he did not see it live on television. He said, no, you didn't. No, you didn't. That was animation.
Lies. So you are saying that they are lying. The people that say that they have walked on the moon, are they lying?
Absolutely.
Okay. Just wanted to make sure that we were on the record.
All right.
Yeah.
We're going to get every tag in the book here, guys. What are you trying to do? All right. So maybe it would be a good time to let you guys have a water and bathroom break if you need to. And we're gonna...
I don't think we need conclusions. We just go right into Q&A. I think we've already had our summarizing bits.
All right. Well, let's.
I'll be back in a sec.
All right. We're gonna jump into the Q&A.
As well.
Perfect. Alrighty, no worries. Well, we're going to jump into Q&A. I want to just remind everybody to get their questions in there. We do have quite a few already. So let's see here. A lot of people tagging me in the live chat. We do have some new topics coming up here, especially with the election coming up. So stay tuned, and especially with DebateCon coming up. That's going to be super interesting. But just before we jump into Q&A, I want to mention first, folks, I've had so much deep focus work lately that I finally tried Magic Mind, and I've got to tell you, it is the best energy shot out there. With ingredients that have been empirically studied over and over, I've used Magic Mind to feel more focused while working on my music, for more mental clarity while setting up these debates, which I have been setting up more of these debates, and so does James. So like I say, stay tuned for that. It has definitely increased my productivity. I know you guys here as modern day debate listeners, you guys are critical thinkers. I've got to tell you, I have felt the effects personally. And I've also checked the ingredients out personally, so you can check them out on Google Scholar. The ingredients are empirically supported, so you'll appreciate that. Use the custom-made Modern Day Debate Magic Mind affiliate link below, and use the code ModernDay20 for the special discount to feel the power of Magic Mind yourself, and better yet, get the Magic Mind subscription for a whopping 40% off with the MDD promo code. Alrighty, so yeah, really lively discussion there, Grayson and Ross. I think I've gone through most of my motions here. Use code Ryan10. You're hilarious there, Razor. We're just going to wait for Ross to get back here. Yeah, thank you guys for coming out and having this discussion. We do appreciate it. I guess I should wait till Iron Horse gets back to say all my
Do
thank
you
yous.
wanna maybe plug that we're trying to get something scheduled for Wednesday?
I should probably let everybody know. So I have kind of been alluding. We're trying to get a debate set up. I'm just waiting on a picture from one of our speakers called The Last Chelly, which I think they're pretty popular on TikTok. Uh, but we're just waiting on a picture from them, and then we're going to be able to host this debate for Wednesday, which is Trump good for America? So Grayson is going to be there. Hopefully, Drew is going to be there as well. I've got to follow up with Drew Pavlov to see if he can come out for that date. But if not, I'm sure that based on other experiences here on Modern Day Debate, if you're listening right now, other people who like to debate on here, Wednesday's your day. If you're wanting to debate from the lefty side, there might be a spot for you. I still have to follow up, or I should say, I have followed up. I haven't heard back because we were hopefully going to be doing that one tonight, but we had a change of plan, of course. So, yeah, once again, we had this poll here. It closed out with 68% saying no, it's not a hoax, and not a hoax, not a hoax. Yes was 24%, and then Gravity Backwards is my orc name with 7%. So you guys are just the miserable trolls that are just having fun, but I just enjoyed making you pronounce Gravity Backwards. Think about it for a second. All right, that's awful. All right, let's carry into that Q&A, everybody. Thanks for contributing. Iron Horse, I had said earlier, thank you to both of our speakers for being here. We really appreciate you in Modern Day Debate, especially with DebateCon coming up. Like I said, it's going to be DebateCon 5. It's going to be in New Jersey, so keep an eye out for some of the ads and the promos that are going to be surrounding that and the dates that we're actually going to get booked for these speakers. It's going to be super exciting, and your super chats really help out in getting these events set up. Grayson, you were at the last event. It was really cool, honestly.
It's kind of fun. I highly recommend.
Yeah, highly recommend. There was some high pressure moments at the last debate con for sure, but we all went back and we didn't have nearly enough beer. Honestly, that was the only problem, I think. We
You
should
live
have
and
had.
learn.
Yeah, exactly. Next time we'll make sure that we order some beer for the hotel room before I invite you all back.
Absolute crime, man.
All right. LJ asks, how do you personally know gravity is not a hoax?
Because of the experiments that show that it exists and is not merely relative density or electromagnetic effects. And those effects can be isolated experimentally. And those experiments have been published, peer reviewed, and repeated. So we can know that gravity exists.
Well, we've never seen mass actually pull something up off the Earth just due to the mass alone. We can see it happen due to electrostatics. We can see it happen due to magnetism or electromagnetism as well, but we can never see it happen due to gravity. So basically, you have to assume gravity is a force, and then you assume then that the things you see are due to gravity and not explainable by something else.
So you've
By the
set up
way,
this very false premise here, where unless you can have one object physically like attract another object and beat the Earth's gravity, then you cannot prove gravity exists, and it's just an assumption, which is a completely false and completely illogical premise. You do not need to have this exact little scenario that Iron Horse has sketched out, where you have one object that's lifting another one, beating the Earth's gravity. You can show and demonstrate that gravity exists using other experiments. This is not the necessary experiment to demonstrate that. Cavendish's experiment demonstrates it. Gravitational lensing experiments demonstrate it. Gravitational redshift experiments demonstrate it, as we've gone over tonight. It's not just assuming, okay? It is actually following the scientific method to develop a theory to explain it and support that by evidence. That's not just assuming your conclusion. That's what Iron Horse has been doing all night.
okay, so we've got something like the moon, for example,
I think it's
which
the
we know to
next.
be.
I think it's the next question, right? I mean, it
Well,
was
I'm
asked
just going to
to me,
say,
and
I'm
then
sure there's not too
Okay,
many
well,
questions.
if you have a response, we're giving Grayson the last word because that was for Grayson.
Yeah, thank you. I'm just saying that, if the moon is 1/6 of Earth's gravity, but due to the inverse square law, you're saying that the moon is capable of pulling trillions of tons of the oceans towards it to create the tides, and somehow magically also create another tide on the backside. I mean, we could probably discuss tides all night because that proves gravity is completely wrong. But the moon would be a good example. It's something of a mass big enough to say that, yeah, why doesn't the moon and the Earth pull themselves together due to gravitational forces?
Because there's also kinetic energy, right? They're moving apart. Like there's a force of gravity that's acting when you throw a ball up in the air, but the gravity doesn't immediately pull the ball back down because the ball has enough kinetic energy so that it can overcome that downward force that's being applied to it. So that's the thing. We keep getting back to this fundamental misunderstanding of free body diagrams. When you need to do a free body diagram, you need to draw all of the force vectors acting upon your object. If you were talking about the moon, and then what kind of gravitational force that the moon imparts on things on the Earth, you can calculate that. Right. And it would not cause things to just all of a sudden levitate above the Earth's surface. You need to do a free body diagram to where you add up the vector from the moon's gravity to the vector from the Earth's gravity, and then you add them together and figure out what the overall net vector is and how that affects things, and that's what causes tides. So that is observable.
We need to move on to the next question there, guys. The next one is coming in from LJ as well. So it's going to be for you, Grayson. He says, the globe religion requires early childhood brainwashing with globe toys and stories. Why isn't that the most massive part of the ISS creating local gravity?
So that was kind of one statement and one question. You could just say literally all forms of education are indoctrination and brainwashing. You could say believing that 2 + 2 = 4 requires that you were taught it at an early age, when in reality you're just ignoring the fact that there's all kinds of demonstrable reasons, evidence, logic why gravity exists and 2 + 2 = 4. You don't just need to believe it because that's what we were taught as kids. You can say, well, hold on, what's the actual evidence that suggests this? And then you can go look at what that evidence is. And there's plenty of it for gravity, just like there's plenty of it that 2 + 2 = 4. These things are supported by the world around us, and we can do experiments to see what that evidence is. And that's what I've shown tonight.
All right. Did you have any response on the other side, or do you want to carry on?
Oh, well, I could easily say that 2 + 2 = 4 is just a simple logical deduction, whereas gravity is a simple logical assumption that you have to have invented in the first place to make the impossible possible.
Last word over there, Grayson.
Yeah, we empirically verify the existence of gravity. Like we do the experiments, we make the predictions based on our models of curved space-time. They have accurate results consistently. This is the entire basis for how all science works. So if you say that, oh, well, gravity is just an assumption, well, then so is literally all scientific knowledge. And it seems like that's where Ross wants to go. I mean, he just wants to say you could be a brain in the vat and none of this could be real. So sure, everything's out of the window, solipsism reigns, and you can't be certain about anything.
All right.
If you can't be certain about gravity.
Let's carry on. And I know some people in the last debate were saying something about me pushing the conversation along with saying, let's put a bow on that. But it was you this time, Iron Horse, that said, let's put a bow on that thought. So somebody always has something to complain about. I think that's the real tragedy here at Modern Day Debate, is that...
I thought it was a good way of putting it, as long as you don't overuse it. Yeah.
All right. Well, I was going to say...
Brian, we're not getting to the next question fast enough. You're too slow.
Oh, yeah. What are you trying to do? Trying to remind me of the other night here where I had to try... Anyways, but honestly... It is one of those strange things where, 9 out of 10 people who agree with you are probably going to comment on the other side and vice versa. You know what I mean? Like, rather than say, hey, Grayson, great job, I really appreciate what you said, they're probably going to say, Iron Horse. Anyway, let's carry into those next chats. Simon says, Ross is I don't know if this is a derogatory term in anywhere, so I don't know if I should say this term.
Yeah, go ahead. Nothing can harm me, mate. It's all water off a duck's back from these.
They say plonker. I don't know if that's derogatory in a buddy's language, but okay. I just had to look it up right quick. They said Ross is a plonker. What is that? I don't know. Um,
Was that the question? Just Ross as a plonker?
plonker, a silly person. Well, you're silly for paying €2 for making that statement. It was read out loud though, Simon. So that
in
Aussie, maybe worth
in
something.
Aussie slang, plonk is also another name for grog or wine or heavy wine. So if you're on the plonk, it just means the guy's drunk or pissed, as we also call it. So a plonker could also be an alcoholic. So yeah, you could be saying that.
Oh well, either way,
I'd say it probably
Simon
falls a
doesn't.
bit of
Simon's not
fool.
making friends today. So whatever Simon says, yeah, you're not making
Whatever
friends. It's
Simon
fine.
says, don't do.
OJ, coming in with another super chat. He is our bona fide flat Earth super chatter. He is always asking questions related to the flat Earth argument, even when we're not having the discussion. I think you guys said it enough times during the debate that we've already gonna get the tag. It's fine. LJ asks, "How is gravity holding down oceans, but we can walk?" That's for you, Grayson.
Why would those two things have to do with each other? When you want to determine what gravity is going to do to an object, you calculate what the gravitational force will be. So you have big M, the Earth, little m, the object that you're curious about, and then the radius from the center of the Earth. So you can calculate that, and you can calculate what the force of gravity will be, and you can calculate that for the oceans. Well, I got news for you. The little m that you're going to use in your equation for the oceans, that's a big mass. The oceans are very heavy, LJ, but you are not so heavy compared to the oceans. So the gravitational force will be less. So there you go. I hope everybody understands basic math here.
Yeah, I'm pretty happy with that too myself. If gravity was a thing, then it would be proportional to the mass and the force it would apply to it. Except as we also see, as I think one of the early experiments, I think it might have even been Galileo who did it, but I could be wrong. But whoever it was that dropped like a small lead ball and a heavy lead ball off the Leaning Tower of Pisa to assume that the heavier one would be more attracted due to gravitation. And they found that it's not the case whatsoever. So the size of the mass is really irrelevant to the rate of drop. And the rate of drop is what you use as your little g in nearly all of your formulas. So again, sort of the very idea of gravity negates itself.
All right.
Just
Last word for you,
you're
Grayson.
confusing.
Unless you want to bounce it, it's up to you.
I thought that was my question, Ryan. I got the final word on this.
Oh, you sure do. I thought you were going to say like you wanted to bounce it there for a second, but you go ahead. It's the last word.
Okay. Yeah, I just want to clarify here that you're confusing force with acceleration, right? When you're calculating what the difference is, those two objects should experience different forces, but force equals mass times acceleration. So then you have to divide those forces by the masses. So then the acceleration is the same number in the end. This is high school physics. We can move on.
All right. We have a question there for you, Ross. So thanks again to everybody for your super chats. Get your questions in. There's lots of questions that are just pumping in now. We really appreciate it. Like I say, we have a live event coming up, which is DebateCon 5 in New Jersey. We hope to see you all there. If you can't make it there, oh, excuse you. Yeah, I get gassy sometimes too. What's going on?
when you're finished, I just want to say that he just turned around and said that the net force is zero, but a second ago he said that the net force of the oceans compared to the human is completely different. But now he says it's the same.
Did you just steal the last word? You just stole the last word. You are so sneaky.
Okay,
That is the sneakiest last word.
I'll have the last word.
How can it be zero and also so different? He's
All
just
right.
Lied and negated himself.
I'm explaining
go
it
ahead.
right
I
here,
give you
okay?
too much time to stew on it.
The thing that is the same, Ross, is the acceleration due to gravity. That's what's the same. The force on those two objects is not the same because they have different masses. If they have the same acceleration, then they have to have different forces on them as well.
But you just said they don't, according to the lead balls dropped off the Leaning Tower of Pisa.
I did not say that. No such thing was said. I said
You
that
did.
let me clarify what was said.
Rewind it.
This is going to be last word for Grayson. We have to ask
Yes,
the next
this
question.
will be the last word. So let me clarify. I said the forces on those two balls due to gravity will be different, but their accelerations due to that force will be the same because of their different masses. Clear?
Not at
What?
all.
Why would
Clear
you
as mud.
ask clear? You're trying to pass the ball. You're being. Oh,
Because it's a very simple concept, and I would really like it if Ross would be able to understand it and agree with it.
You just negate yourself. You contradict yourself. You obviously don't understand it
all right.
yourself. So
All
let's
right.
move on.
I'm gonna cut you off all there because we have questions. Like I said, they're pouring in.
Let's get to the next question.
Lots of people have all kinds of things to ask of you guys, and we really
Let's do
appreciate
it.
it. Like I said, I was trying to do my housekeeping, and you guys got all excited
Next
again.
question, Ryan. Next question.
I know you guys are gonna stew for too long. Kango44 says, Ozzy, why is it more difficult to carry a weight upstairs or a slope than along a flat surface?
Why? Um, because you're going uphill. You know, it requires force to go up. That's basically, I think, the whole point of the fact is we're talking about a universal up and down. In order to go up, you require greater force of resistance. And in this case, you've got to use your physical exertion of your own body to go up using obviously the shape of the terrain or you know the landscape around you, whether it be a stairway or a slope of a hill. That is a real example of actual curvature of the earth being a hill. Whereas otherwise, if you're walking on a flat surface, well, you're just carrying on forward momentum. You're not sort of fighting an upward force.
That is exactly correct. The difference is that you are not fighting the force of gravity. Whenever you are
Puts it
moving
down.
something on a flat line, on a flat plane, you're not fighting gravity. But when you're moving something up, you are having to fight the force of gravity. So you're having to supply your own counter force, which takes energy and work. That's why it's harder.
Yes, and on the spaceball model, you're either going up curve or down curve. It's hard to say because apparently you're always on top. But either way, you should be using that to your advantage. But obviously, we never do. So
That's not how this works.
I get the last say. So shut up.
Oh my, aren't you guys friendly? Well, I'm going to close out the poll that we have in the chat right now, which is the no choice but to hit the like button, everybody. It's yes. And remember, smack up. They don't like it when you smack down. That just hurts. That hurts the old rumpus. So let's end that poll. I'm going to put a new poll in the chat. One that's going to be who brought the best arguments to the table tonight. So just keep an eye out for that. And I'm going to ask the next question while I get that ready. And if you got more super chats, like I say, get them in because, like I said, with the live event coming up, we need all the help we can get to get that off the ground. So Kango44 says, Ozzy, you know a helium balloon goes up because gravity is pulling the air around the balloon down, right?
No, that's what I actually said in my opening introduction with the push me pull you sort of effect is the same as with the vacuum, is that you could say that the atmospheric pressure is forcing itself into the vacuum when the valve is released, or you could say that the vacuum is sucking the atmosphere into it to create an equilibrium. So for the same factor, you would say with a basketball, well, if gravity exists, it's also pulling the air down. So why isn't the basketball rising into the air? The only reason we can explain why the helium balloon rises is because of its relative density to the medium of air, makes it lighter than air, and so it itself is pushing itself upwards. It's not gravity pushing it up. It's not an anti-gravity device. It's just the relative density of the object to the medium that determines whether it goes up or down.
So the questioner is exactly correct. The reason why the helium balloon goes up is because the air around it is being pulled by gravity down, and so then the force from gravity is going to be impacting it more because it's more dense. It's going to be pulling it down stronger than the helium balloon, which will be pushed upward by that force. That is the explanation for what is causing the differences in motion when you have something that has the differences in density that Ross is talking about. It's not just that the differences in density create this motion of the balloon to go up. It's that there's a gravitational force affecting the air and the balloon. And the air is pushed because it's more dense than the balloon. The air is pulled downward and the balloon has to be pushed out to make room for the air. That is what's happening. So you can't just assume that, again, the relative differences in density do not explain this, because you could do this in free fall and you get totally different results with the same densities.
Okay, you said an awful lot there, but you basically said the same thing, that is easily explained by the relative density without the assumption of gravity in the first place. Done and dusted.
All right, let's carry on, and I'm gonna fire that poll into the live chat. And yes, I am a beggar for those likes, everybody. Oh, what are you doing over there, Grayson?
That was you firing the poll.
Ooh, yeah, firing
You're firing
the poll.
it into the live chat.
Oh man,
Bombs away.
I'm trying not to make any inappropriate jokes, but my ADHD brain is just firing now. You can't use me as a launch pad like that. Jungle Jargon says, Grayson, the lack of gravity is observed to cause a superliminal of motion away from the center of the mass of the gravity. Oh, sorry, of the galaxy. Sorry. The lack of gravity is observed to cause a superluminal motion away from the center of the mass of the galaxy.
No, it doesn't. That's actually just complete BS. The thing that causes galaxies to move superliminally, as in faster than the speed of light, apart from each other, is because space-time in between them is expanding. It's the expansion of space-time which is driving this apparent superluminal motion. It's just because the amount of space in between them is getting bigger. It's not because they are actually moving faster than the speed of light because of some lack of gravity. That's just made up jungle jargon. Sorry.
All right, any thoughts on the other side there, Iron Horse? Do you want to carry on?
I'm happy to let that one go.
He's letting you go. He's letting you go by the scruff of your collar. All right. Well, thank you once again for your super chat. Let's see. Next one coming in from DJ Moss. His question for Ross. Why don't, I think he means, why doesn't mercury go through granite? Even granite is less dense.
Well, that comes down to the basic properties of matter, solids, liquids, and gas. And solids basically are solid by definition because they're impenetrable. Some of them may have some sort of absorbency rate, such as wood, for example, sitting in water for long enough will absorb water and will start to sink rather than float. But granite is pretty well impervious to liquids, and mercury, being a liquid, will simply roll off.
So why, if we put a bunch of mercury liquid on the bottom of some granite, why doesn't it roll up? Because you're just assuming that it should go down for some reason, because you're just assuming it should, because it's circular. It's a begging the question fallacy.
Okay, so you're talking about some sort of tub of mercury and putting the granite in it. Well, again, that just comes back to Archimedes' principle, is that its weight relative to the mercury will be displaced and it will float in it. That's different from putting it on top of granite and it penetrating through the granite.
But you acknowledge that you are just starting out pre-assuming the downward direction.
Of course, yeah.
Okay.
Of course.
As long as we understand that that is the starting presupposition to all of this. It seems like we have lost Ryan as the moderator. I'm not even sure if we're still live.
Well, that's fine, because that's what we have a container for. Like the swimming pool has a container because of a liquid needs to be contained, and any part of it that becomes higher than the edges of the container will flow and seek another level.
I would love to talk about if you can have pressure without a container, because I can show you that you can.
I'm just talking about liquids require a container.
Oh, I'll show you a liquid that doesn't require a container. Are you ready? A drop of water on a surface. Could be granite, could be a leaf. You have a drop of water right here, and it's a drop, right? So there's a pressure, a uniform pressure throughout this drop, pushing in all directions. And yet, there is a border for this drop of water. This drop of water is contained in a shape that's not just being contained by the ground. It's being contained in that shape, and it's only bordered by air. There's a pressure differential, and yet those fluids are not equalizing.
All right, last word for Ross.
So what's holding it in that shape? What container?
That's called surface tension.
Exactly.
And obviously, gravity is impervious to it. Gravity can't even do anything about it, which proves gravity is not a thing. Surface tension is a thing.
What causes surface tension? It's a force, right?
It's viscosity of water itself. If you added a tiny little drop of detergent to it, you'll break that viscosity. It's due to its own molecular makeup of
Exactly. It's
hydrogen and
because
2 parts oxygen.
exactly, Ross. You're almost there. What is containing that water pressure, that water droplet, even though it's fluid with a pressure, what's containing it, even though there's not actual physical container there, what's containing it in that shape is the intermolecular attractive forces between the water molecules. That's what it is the attractive force.
All right, we gotta give.
Yeah,
We have to let Ross have his last word.
And that's because it's a liquid. I beg you to try and do the same thing with mercury sticking to the bottom of a sheet of glass. You couldn't do it because it's
1 second, Grayson.
Because it is far more dense, and so it will not be able to be held up by the sheet of glass. The mercury might do that on the surface of something, but it have to be the top surface. That's viscosity, density, and surface tension. Very simple stuff that applies to liquids.
All right. Can I get the last word on it? Or can I get one word and then Ross gets the last word? Because this is really important, Ryan.
Ross had the last word.
This is up to Ross. So, Ross, if you want him to answer, if you want to pass it on.
And then you can have
I think we've had the last word. That's it.
All right. We're going to carry on to the next question. Sorry there, Grayson. It's only fair. We got to follow these rules. I know you really want to respond here, but we got to follow the rules. So LJ is asking for $1.99. Pyramids and cathedrals were built before gravity. And then a big he's just like clapping his hands and having a good time over there.
Well, it's obvious that this one is too stupid and is a joke. So, actually pretty funny.
All right. Do you want to carry on?
I think, basically what he's saying is, what he should have said anyway, is that gravity exists whether we're aware of it or not. But basically, they also were, but when it comes to the cathedrals, of course, they have a lot of the cement. What's the word for it? I forget the correct word for it, but to do with the acoustics, some cymatics, I think is the word.
Oh, yeah.
A lot of their windows and stuff are made according to certain frequencies of sound, which we can replicate today with something as simple as sand sitting on a drum and applying the sound frequency to it, and the sand will form into those particular shapes. So obviously they knew about things way in advance than what we even still know today. So who knows how they built the pyramids, possibly pre-molded in forms made on site out of rock dust and hempcrete. But anyway.
You actually have a pretty good idea of how they built the pyramids because they drew pictures of them building them. And so we know that cymatics was not involved.
All right, next question coming in. Kango44 says, for Ozzy and LJ. He's coming at you, LJ, in the chat. Oh, Kango, you're too precious. All right, catenary? Am I right there? Catenary arches are strong because they redirect the vertical force of gravity into compression forces pressing along the arch's surface, or the arch's curve. Has been employed in buildings since ancient times. Sorry, so there's a couple little typo issues here, so sorry if I've worded this badly, speakers, but did you pull from that one? Maybe we need to.
Yep.
I believe so. I believe he's talking about archways used in architecture, and how they've discovered that because of the density of the bricks pushing down on them, it actually reinforces the strength of the arch, so it makes it a stronger building structure. It doesn't necessarily imply gravity whatsoever, because everything has its own density, its own molecular weight, and then the volume of it determines the weight. So therefore, its own density can be what creates the strength of the arch support.
Yeah, so I completely agree with Iron Horse on this. If you presuppose an already existing downward acceleration of 9.8 meters per second, then there's no need to assume gravity to explain these results, because you can explain these results without gravity. All you have to do is presuppose a constant 9.8 meter per second downward acceleration. That's all, not gravity.
Yeah, and obviously, we can't build this archway sideways and then just travel 4,000 miles or 6,000 miles around the Earth. So that's now, what's that? At a right angle to where we built it. It's now facing the right way downward, so gravity's pulling sideways in, and so now it suddenly works according to that structure. I mean, the very idea is ludicrous. Same as with flights and that going upside down. Everything is built in a universal up and down. All archways are done that way everywhere, all across the whole wide world.
All right. I think it would be good to move into the next question. And yes, members do get a free chat once per month. So if you have a question and you are a member, I will ask your questions. That's part of being a member on Modern Day Debate. As Sunflower is here as saying, gravity is a pseudo force. Grayson, take
That's
that.
true. No, that is true.
It's coming at you.
No, I mean, I made that point. I made that point on my very first slide of my introduction. So Sunflower must have missed it, where I clarified that in general relativity, gravity is a pseudo force, but you can still measure pseudo forces in newtons, thus corroborating their existence. So you can measure centripetal and centrifugal forces. Those exist. They're pseudo forces. They're measurable in newtons like all other forces, just like gravity.
I don't think that you understand what the word pseudo means, and therefore you clearly don't even know what you're talking about. If you think you can measure something that doesn't exist, then sorry, that's not reality.
Pseudo is basically meaning not genuine. All right. I know what pseudo means. I know what a pseudo force is. Okay. And pseudo forces, like I've said, like centrifugal forces are pseudo forces. They can still be measured in newtons like all other forces.
Well, I disagree with you that centripetal and centrifugal forces are actual forces, which
I never
have
said that,
actual
did I?
Last word
You
for
did.
Grayson.
You just said they're pseudo forces.
Last word there, Grayson.
Okay, so it is my last word, Ross, on this. So let me just spell this out very, very clearly because you seem to be missing something in the crosswires here. Gravity is a pseudo force, not an actual force. However, pseudo forces can be measured in newtons just like actual forces. Period.
All right, let's carry on. And yeah, sorry if I read into that Sunflower. I know how you like to come at people, so I might have just been putting some bias in there as far as what I know about you as a person when it comes to making your chats. So it's usually very spicy. Kango44, Galileo realized that the measurement of motion depends completely on your frame of reference. I wonder if in 380 years, people will be teaching Ozzy's misunderstandings of physics. And then for the spice, they say clown. Kango.
Kango the clown. Oh, that's his signature, is it? That makes sense. Kango the clown. Galileo made observations depending upon where he was observing them from. Gee, that's probably a sensible way to make observations, actually.
He was saying that motion is relative. That's what Galileo observed. Galilean relativism or Galilean relativity.
Well, again, we could go back to the hypothesis that you brought up. Basically, the way I'd say it is when you're on a bicycle, you're actually staying still and cycling the whole universe around you. But in order to get everything to move in all the completely different directions, it's far simpler to say that the universe is still relative to you and you're the one cycling through it. So let's not bring in relative motions when we know that what's the difference between an imaginary motion and real motion.
It was his question, right? So he gets the last word.
Yeah, let's carry on. Once again, big thank you to both of our speakers for being here as long as they have. I always like it when our speakers get up and actually take advantage of the bathroom break, because the people that don't, I just sit here wondering, like, do you have a catheter in? What is wrong with you? Like, we're talking about, like, and liquid in a container here, like, I got a small container, guys. I got a piece every once in a while. Kango44 says,
Ryan, a container is not necessary for my liquids. Only the force of my will.
Oh, okay, there. Calm down, Obi-Wan Kenobi. All right, so Kango44 says, Ozzy, why don't the oceans rush to fill the lower pressure area of the sky above them?
Because they're more dense than air, and that's why it rains downwards and water is collected on the earth in the density of the earth, and that's why it will always seek a downward motion from anywhere of higher topography towards lower to the final point, which we call sea level. When water evaporates, it reaches a condensation level, which we call clouds, and when it reaches sufficiently saturation, that's when it, again, due to density, falls back down and will seek and return back to sea level. Why the heck would it do the opposite?
So that was really cute because you just heard Iron Horse say that's why down. But in reality, we all know that he already admitted that he has to presuppose the downward direction of this acceleration before he even starts. So none of that was an explanation for why things fall downward. It's just an explanation once you already presuppose that they should go downward.
Well, yes, I may have presupposed that, but the fact is, I've done that from millennia of observations of since the beginning of time, where anything of more density than the air always does go down. So it's not really so much a presupposition as it is an observation of common sense.
So you started this by talking about Occam's razor, who has to have the most parsimonious explanation with the least amount of assumptions. I do not have to start my explanation with an assumption that it should be a downward direction, because my model explains why the direction is downward, because mass attracts mass. But your explanation, you have to have that assumption, so therefore you have more assumptions, therefore Occam's razor should favor gravity.
Last word for you, Ross.
Actually, that's where you're completely wrong, once again, because gravity itself was also taken from the same observation, and then it had to come up for why it also works on the bottom of the ball, on the side of the ball, all directions on the ball, whereas the observation already existed where, from everybody's point of view, there is a universal up and down before we make the assumption of the ball in the first place, where we don't need gravity.
All right, I want to clear up some smoke here right quick. Peter, in the live chat there. I am sorry if I missed a membership chat. Most people put them in where they show up in the super chat. So if you put something in the regular chat, I may have missed that. I certainly am not going to skip over reading the super chat that you put in. In fact, I'm going to read it right now, and you let me know if that's not what you intended, and I'm going to be in that live chat actively to ensure that your questions get asked. So Peter asks, can both of you steel man flat or globe Earth?
Okay. I can see things from farther than I think that I should see. Therefore, the Earth can't be round.
Okay.
Well, the Earth must be round because we go around the sun, even though there's only 24 hours in a day. And on a 24-hour clock, there's only 360 degrees, but we still measure 361 degrees every 24 hours. And we just call it sidereal day because we're smart. And that's why we have leap years.
All right. I think we got the best we're going to get out of that. So yeah, thank you, Peter, for the super chat. If there is a membership chat that you meant to put in there, like I said, and I missed it, I am sorry. Just remind me in the live chat. I'm keeping an eye on it. I'll ask a question just for a member. That's cool, right? Like, it's totally cool. JSS Tiger says, to the flat earther, orbits aren't just about gravity. They also involve tangential velocity, and orbit is harmonious result of gravity and tangential velocity.
Well, I'm glad he brought that up, actually, because I was hoping to bring this into the debate at some point. It will take me a couple of seconds to explain, but let's just assume, say, example, you got a fly buzzing around you and it's just at arm's length the whole time and you can't quite hit it. So you would say that it's orbiting you. That would be a correct definition of an orbit. But let's say then you jumped on a push bike and started riding down the road. Now, instead of just going around and around you, the fly is actually going way ahead in front of you. Then as it comes around, it must suddenly stop, do a sharp turn, come back around, and then speed up and accelerate again to get back ahead of you. And so it's no longer doing a round and round thing. It's doing this huge, big loop-de-loop-de-loop thing. So that's basically what an orbit is, the tangential velocity plus the gravitational attraction. You throw in a third body of that and something else is going around the fly, like the moon going around the Earth. It falls into the realms of absolute impossibility. Orbits actually make more sense if things are just going around and around in circles, as we observe with time-lapse photography the stars are doing. Therefore, we think the sun and moon are also doing in sort of lower and closer loops, so we only see it for half the day. But the idea of it doing it in outer space with no means of braking, no means of acceleration, and no means of steering, apart from gravity itself, turns the whole shebang into a ludicrous argument whatsoever, and it completely debunks heliocentrism.
Right. So that's why all of our very simple simulations that can model these using very simplistic gravity formulas and algorithms for their behaviors, simplistic formulas and algorithms, they can replicate an orbit. No information about steering or braking. Acceleration is caused by forces, which can happen in space. This is pretty well known. Forces cause things to accelerate. That's the whole point. And so that's what causes things to accelerate. Gravity is all that's sufficient to explain for orbits. The thing that Ross is missing when he's talking about the little fly and how they're all moving and it throws everything off is that momentum is conserved. They're starting out with the same momentum as they all move together as the same system, and they're not losing that momentum at all in the whole process. Their total momentum is conserved. And if you run this scenario in your head, when you actually understand the conservation of momentum, you'll see that it makes complete sense. And that Ross is just saying that this doesn't make sense to me, therefore it must be wrong. It's just personal incredulity. That's the only argument he's offering, is that he doesn't understand, so it must be wrong.
Well, that's absolutely false. It's because I do understand it, and I'm not just obfuscating it in this conservation of momentum. And I also understand that we have the third body, such as the sun, going over 500,000 miles an hour in another perpendicular direction, that the whole entire shebang is what we're known as the third body problem. There is no computer simulation in the world who can solve a third body problem. And just in our Milky Way galaxy, in our solar system alone, we've got something like an 88 body problem. It's just ludicrous. It's impossible. None of it works.
You can solve three body problems with numerical methods. It's been known for decades.
No, it's not. It absolutely is not.
All right. Next question coming in. It's not really a question. It's one for me. Fate says a $2 Canadian. Hey, it's Canadian. It's just a shout out to Oh Canada or maple lovin', beaver lovin'. All right, it says for your suffering, Orion. I can't imagine. Oh well, thank you, Fates. I'm not suffering at all though. I'm having a lot of fun. There's nothing wrong hanging out at Modern Day Debate with Grayson and Iron Horse. These guys are pretty amicable despite their differences here. So I think, once again, you got to appreciate the speakers that we have here on screen.
I would get a beer with Iron Horse. I think it'd be fun to hang out.
Oh, yeah. I was going to say, that would be great for everybody. Yeah, Iron Horse, I don't think you'll probably be in our neck of the woods probably any day soon. I don't know what your travel plans are looking like. Oh, no, that's all right, though. All right, let's carry on. RT16 says, for us, did I read this one? No, I didn't. Sorry. For Ross, if bases are more dense, why do they keep getting dropped? This is a $20 question, and he's got a couple things built in here, so we're going to take it just one slice at a time.
He's making a joke. He's just talking about dropping the bass in music.
I was going to say, I didn't understand what it meant.
What's wrong with having fun, Grayson?
Okay, can he?
I don't want to be a buzzkill. Okay.
Can you repeat the question one more time, then, and I'll see what I can come up with.
By the way, Occam's razor states that whatever has the fewest assumptions. Any thoughts on Occam's razor in regards to our discussion?
That wasn't the base question, anyway. I was waiting for you to get to the base question, so I didn't even get what you said then.
Oh, you think there's a base question beyond that?
No, he's asking you to repeat the question, Ryan.
Oh, sorry.
In a parallel unit.
Sorry, he says, by the way, Occam's razor.
Oh, no, not that question.
Oh, so the first part says, if bases are more dense. I have to repeat this. If bases are more dense, why do they keep getting dropped?
Well, that would make sense, wouldn't it? Because they're more dense. So that's the way it works. The more dense thing drops through the less dense thing.
All right.
Okay.
By the way, Occam's razor states that whatever has the fewest assumptions, well, they're making a statement about Occam's razor and what Occam's razor states. So do you guys want to maybe, like I said, they spent $20 on this question, so if we can get something out of it. Do you guys want to talk about how you might think Occam's razor interacts with the other person's arguments? I'll let you go first there, Oh, Grayson, you're ready to go. I was
Oh,
going
I
to
was
get
gonna
to
say
iron.
we did cover this already. We did have this debate about like how I said that I'm making one less assumption than Iron Horse and that I'm not assuming the downward acceleration at the start, and he is. So that's one more assumption for him.
Well, actually, that's not the case at all. I started my debate with, or started my introduction with talking about Occam's razor, talking about assumptions. And again, your assumption is that everything is falling towards the center of something that's already assumed or has to be assumed in the first place. We don't even have to assume the center of anything. We just make the first observation without assumption that everything has a universal up and down thing without any assumption. And so then when we realize that it does so because of density, that's the explanation. There is no assumption whatsoever in my explanation. You've got several assumptions. First, that it's a sphere. Second, that it has a center. And third, that everything falls towards it because of the bigity of the sphere that's invented, that's never even proven to begin with.
So, first of
Assumptions.
all, not an assumption. We can directly observe that objects rotate around the center of gravity. We can look at binary star systems where the center of gravity is actually not an object, it's a point in between the two stars. And we can see that all the planets rotate around the point in between the center of gravity. That is a direct observation that things rotate and are attracted to the center. So this is observed, not assumed. And yes, you did already admit, Iron Horse, to assuming the downward acceleration and the beginning. You are saying that this downward acceleration is caused by the differences in density, but you already have to assume the downward direction to start. And you admitted this, and now you're backtracking, but you know deep down that your model must start with the presupposition of the downward direction of this vector.
The presupposition is an observation. It is not presupposed. It is not invented. It is not assumed, but is already observed. An orbit, as you've just described, around the center of attraction or center of gravity is the complete opposite of what gravity is, which is the downward bias towards the center. So orbit and downwards, I don't see any people orbiting the Earth. We're stuck here because of gravity, and yet you've just said that things orbit because of gravity. Make up your mind. Sometimes it orbits, makes stuff orbit. Sometimes it makes things fall down. You can't have both. That's just ridiculous.
You actually can.
Everything about your model is ridiculous.
The difference and why you can have both is the difference is kinetic energy. If we imparted enough kinetic energy to you, Ross, and I picked you up and I threw you with enough kinetic energy, I could throw you into orbit around the Earth. That is theoretically possible.
No, you couldn't.
Yes, you could.
It's theoretically impossible.
Nope. With enough force, I could throw you fast enough to where you would orbit the Earth. That's a fact. You would be dead, but you would orbit. Your body would.
You'd have Superman.
I would never keep up with the speed of the Earth orbiting the sun.
Big ass. Oh, man. That's fun, guys. The next part says, for Ryan, sorry about the fart last time. He asked me to make a fart sound effect, and I'm very good at making those fart sound effects. I have kids. You get good at it. All right. He says, I'll end this one differently. Banana. I don't know if he wanted me to do like a Jordan Peterson or a Kermit, like a banana or a banana. Or what else we got? We got Arnold Schwarzenegger. Oh, it's a banana. Everybody eat a banana. All right.
Bill Cosby, go.
I can't do that.
Let's talk about the banana pops.
There you go. Do you have any Iron Horse, any impressions you want to pull out for this fella? Let's carry on. This is fun. Oh, man. Yeah, let's see. Astro Kate Shathax? I don't know. Ross's beard makes me think he's a Unix admin. What is that?
What?
What is this?
No idea.
Grayson, do you have an idea what this is? UNIX. I hope I'm not saying another slur. Are you guys making me say another slur? You stop.
I assume that it's some sort of computer science programmer thing. It's not my wheelhouse, but that's what I'm assuming. So based on context.
All right. Leo Cartwright says, hey, Ross, I would like you to do an experiment right now disproving gravity.
Disproving gravity?
Mm-hmm.
That's not how it works. The positive claim requires the positive evidence. I'm just saying it doesn't exist because it's superfluous to any of our requirements. Relative density explains every observation. I don't need to create any invisible forces of attraction to prove a theory when that's the burden of proof is upon he who makes the positive claim.
So, as I've already pointed out in this experiment, relative density absolutely does not explain everything, because you can set up an experiment like where you are testing, do things fall because of relative density? You do not change the relative density at all of anything involved. Relative density is not an independent variable here. What you change is whether or not your experimental chamber is in free fall. And when that's the experimental parameter, you get a difference, but that difference is not explained by density. And this is how we know for a fact that density cannot be what is the explanation for this acceleration from gravity. It cannot be density, and that experiment proves it. And yes, Ross, you can prove negatives. They're just harder to prove. There's nothing illogical about it. If I claim to you, my car is not currently in my garage, I could demonstrate that to you. That is a negative statement that can be proven. You can go to my garage and look.
It's still a positive claim about something, just to say that it's not. But,
if I'm saying my car is not in my garage, like that's a negative. It's like you saying that gravity is not real.
You have proven that density can in fact be infinite with your claim about things falling at the same rate. Because again, we've talked about, you said something about dropping, and then you're talking about them dropping. You can't have a dropping thing dropping. It's not how it works. Everything is dropping at the same time. So when you put it in free fall, that is already dropping. So why would you expect anything to drop more than it's already dropping? It's just crazy.
Ross, here's the key reason why. Because there is a relative density difference, and you're the one who's saying that this dropping is caused by the differences in relative density. So if
it's already dropping, mate. It's already dropping.
Yes, but the relative density is still there, and so that should cause a drop within the dropping system. There should be a further dropping because of the relative density.
No.
That's
you just
according to your model. Yes.
There's one dropping. You cannot have dropping
understand your own model, sir.
No. You are trying to claim something extraneous that we never claimed, that you can have dropping within dropping.
It is necessitated
by your model. I'm just going to inject here, guys. We've been going back and forth with this one. So, Grayson, you said Iron Horse doesn't understand the model. I have a follow-up from Peter. He wants you to steelman. He wants you to steelman Iron Horse's model there.
Sure.
So
okay, I can do
he
that.
wants you to do your best without,
I can do that.
making comedy as we did the first time.
Okay, so because every time we look on Earth, because we cannot trust any non-terrestrial experiments because those are hoaxes. When we look on Earth, what we see is that things always fall down. So that gives us, we can just assume that because we observe it every time on Earth, we can assume a downward direction. From there, we can determine if something will rise up or fall down based on its relative density to its surroundings when we account for that pre-assumed observed downward acceleration vector. When we assume that is the case, you can use relative density to describe what will happen to an object. There you go.
All right. Hopefully that answers your question there, Peter. And we do appreciate your support here at Modern Day Debate. So, like I say, keep your eye out. We are trying to diversify on the debate topics that we've had on recently. So, like I say, keep an eye out on the channel with new developments fast approaching and all kinds of political developments. We've got to get into the fire. We've got to. All right, so Leo Cartwright says, hey, Ross, I would like you to do an experiment right now disproving gravity.
I think we did that one.
Okay. Did I already read that
one? That one where I said, the burden of proof is on he who makes
the... Some of them are going to ask you similar things. Sorry about that, guys. JSS Tiger, it was worth double the money, right? JSS Tiger says, to the flat earther, orbits aren't just about gravity. They also involve tangential velocity. Oh, I already read this one too. See, I scrolled up way too far. Or I did that thing where I scrolled back and forth, and now I've forgotten where I was.
Can I just quickly ask Grayson, how does he believe that it's a presumption when it is also an observation? Well, surely the observation is made without presumption.
Well, I'm trying.
So he didn't really steelman the flat Earth very well at all. He actually tried to throw in his global bias by saying that's a presumption when it's an observation.
Okay.
But because it's technically it's not an observation, because you can observe like outside of the Earth's gravitational systems,
No,
or
you
you
can't.
yes, you can, Mark. Yes, you can, Ross. That is why it's not just like it's an assumption on your part, because we have evidence to the contrary, but you reject that evidence because you just think any evidence to the contrary must be fake because it's contradictory to you.
Didn't say fake, just said non-existent. You
All right,
don't have it. You're
let's
just
go to
making
the
it up.
next question. I swear I hadn't read those ones yet, but maybe they're very similar to other ones that had already been read. So
Oh, you
sorry
read
about
them.
that. Oh, go. Oh no. Yes, I'm getting that that old man short-term memory loss. Right. A lot of people are asking me the other day when I said my daughter has turned 10 how old I am. I'll just let them
Oh, you
stew.
already told us this story earlier, Ryan.
No, oh did I? Oh no, my brain. All right, made by
No, no, I'm just gaslighting you now.
I know. Made by Jim Bob says, Grayson, how was curvature in space-time manipulated as an independent variable in order to conclude its assumed effects?
The independent variable is the actual gravitational force between the objects which you're manipulating, which is exactly what Jim Bob is talking about. So you are manipulating the curvature of space-time locally when you are manipulating the distance between these two objects. Because remember, gravitational force has distance, the radius, on the denominator of the formula. So when you are manipulating that distance, you are manipulating the gravitational force between those objects. That's why it's the dependent variable. That's why the actual spatial curvature, which remember is equivalent to gravity, is being manipulated as a dependent variable by manipulating that distance between the objects.
Find that very interesting because space itself really is nothing. So I
No,
don't
it's
see
not.
why the amount of nothingness between things should vary how much their gravity works on one another. But anyway,
It's quite simple. Space is not nothing. That is just not true. Space has an inherent amount of energy to it. Space is not nothing. Nothingness has no space or time. So space is not that. Space exists, therefore is not nothing.
okay then.
All right, let's carry on there. It seems like we might have to get Teens Player one of those modern day debate handkerchiefs. They've just been crying and crying in the chat. Something to dry your tears if you're going to keep crying so much. All right, David says, Grayson, if gravity is real, then why is Google so Wednesday on alternate purple weekends? You can't explain that. Checkmate. What do
Why
you?
is Google what?
He says, why is Google so Wednesday on alternate purple Wednesdays? Or weekends. So alternate purple weekends. You can't explain that. Checkmate.
He's right. He's got me. I cannot explain that. I have absolutely no idea what he's talking about. I can't explain it. He's got me. I concede.
I'm not sure what he's
See
talking
that.
about either. Do you know Iron Horse? I think he's
Uh,
joking, maybe. You can clarify in the live chat, David, but
it goes way back into the time talking about Odin and stuff. So yeah, it would be here all night discussing it. So let's just go to the next one.
okay. Nominal one of our membership chat says gravity is scientific with a lowercase g. Gravity, capital G, is scientism.
Uh, I have no idea what a proper noun gravity means versus just a more general noun gravity. It sounds like a bumper sticker, to be honest, but it doesn't sound like a very well thought out logical one.
I think he's saying like big G and little G mean different things in your different formulas because everything in your whole
Oh, he's
belief
talking about the
is
constants.
magical. Yeah.
Okay.
So yeah.
Okay, well, both of those constants are empirically determined. So if you say one is a fiction, then the other one has to be a fiction. If you say one of them is reality, the other one is because they're both determined through the same scientific method. So,
All
Yeah. Well,
right.
they both just mean weight. So yeah. And time over distance over time is not a force. So
Let's carry on there, fellas. Jiffy Jipwald says the LIGO detected gravitational waves. Game over for flat Earth. Thanks,
true.
science.
True.
Let's let you respond there, Ross. So that we're going
I
back
don't
to
see how
what
it
Grayson
affects.
brought up.
I don't see how it affects anything one way or another. To be honest, like we can see things happen out in space, out beyond the firmament. Doesn't mean that it affects anything down here on Earth or has anything to do with what happens here in the physical realm. So You can believe what you want, but
The reason why LIGO, just by itself, the LIGO experiment makes flat Earth impossible, right? Is because one, I mean, it had to be perfectly straight. Level was not straight enough because level curves with the surface of the Earth. If you accept that LIGO exists and is what the scientists say that it is, the scientists and engineers who built it, if it is a perfectly straight line that is not level, then the Earth is not flat. Just the existence of LIGO, even before they turn it on, already disproves flat Earth. But then it gets worse because there's two LIGOs, one's in Louisiana and one's in Washington, and they can talk to each other because and they can detect the gravitational wave, and so they can determine who detected it first, what's the difference, and guess what? It perfectly matches what the globe Earth model says should be the differences in detection times between those two signals. But it doesn't match for a flat Earth. So again, LIGO defeats the flat Earth entirely.
you've got to be kidding me that over such an extreme scale, over thousands of billions of light years, that the distance of a couple of 100 miles is going to make all the difference that you can measure in terms of units of time.
You can
The
calculate
fraction
it.
of difference would be instantaneous. You could not calculate it. It obviously proves that these things are happening much nearer and more local, and that it's all local events happening that could give a possible time dilation whatsoever, time difference.
So I know that Ross is really incredulous and doesn't think that you can, but in fact, we
No,
could do
I
the
don't.
math and we could show the math that it is you can calculate what the difference should be, and then you can look at what the actual data is, and you can show that that exact difference that was calculated was also measured in reality and matches the calculation. We could do
It
all that.
would be so insignificant compared to the overall distance in time that
Yes.
there would be no difference.
It's
All right, we're
Zero.
small, but
pushing on.
measurable.
We're pushing on there, fellas. I think we've had enough back and forth on that one.
I only needed
All
4 words.
And once again, I do apologize to anybody in the live chat if I did repeat any of the super chats. You know, I've been hosting debates since May 2nd of last year, 2023, and sometimes the questions do look similar to other ones I've read. Over the little bit of time that I've been here. I imagine it'll get worse, and Grayson will be here saying, "Oh my God, this old man," as my gray comes in. Ozzy, aerogel is an open lattice that is less dense than air. But since it's in the air has suffused it and weighs it down. So air, less dense than air, but still goes down. Please explain. From Kango44.
Well, air itself is actually not a physical, tangible object. It's a conglomeration of a whole heap of virtually weightless molecules of gas. So the aerogel thing, even though it might be less dense than air and lighter than it, it still becomes a tangible mass. And so it's not just going to float around like an individual gas molecule. So, of course, it will find a place in the physical realm on top of something more dense that will physically resist it. Air is not actually physical in that sense. It's very, very fluid.
Air is absolutely physical. It's made of physical molecules and atoms. So what Ross is trying to get at is that these air molecules are only like they're barely any attractive forces between them, holding them together into a solid object. It's the chemical bonds or the strong intramolecular forces that are holding the physical components of these phases of matter together into solid objects. That's what he's getting at. But air itself is completely 100% physical.
Yes, but it's not a physical, tangible object. It's many, many billions and trillions of tiny, tiny, non-physical, basically, molecules. So yes, it's physical. I didn't say it's not physical. I just said it's not a tangible mass. It's billions and billions of tiny things constantly.
Just say it's not a single object.
Yeah, you know? it's very fluid. I'm not saying it's like fluids, two different words.
It is a fluid.
It is very fluid. That's correct. Yeah.
Okay, we should probably just move on.
All right, let's move on for sure. before I have too much fun having Yu-Gi-Oh nostalgia with the people in the chat. All right, Kango44, thank you so much for your questions. We really appreciate it. If you have any other questions, that seems to be the end of Kango's questions, actually. So, yeah, if you have anything else to ask, feel free to add it on. Gravity X says, how much LSD does it take to think you can fly? I mean, I've only experimented with very legal things, so I don't know, Grayson. Has anybody flown? I don't know.
Yeah, so your own personal mileage may vary. Like you could, if you're, an especially person of some mental fortitude, you could take 10 hits of LSD and you could be
No.
able to navigate a subway. But somebody might take one hit or half a hit and totally lose their mind and think they could fly off a building. So it's just it's down to the individual person, how mentally how strong is your mental fortitude, how willingness are you into giving into your own delusions, and how predisposed you are towards like mental illness.
I'll stay in Canada with our indica and sativa. Over to you, Ross. Did you have anything to
Yeah,
say to the super chatter?
yeah, I didn't realize Grayson would be such an expert on the subject. Must have had a lot of experience with it. But I'd say basically it comes down to how much indoctrination you've got from your nautical training centre, so that when you're back in the late 1960s and you're given enough of it and you go through enough simulations, you might even
Hey,
believe you went all the way to the moon and back.
hey, hold on there, Iron Horse. Just for 1 second. Just if you could. Picture yourself on a boat. No, I'm kidding. I'm not going to do Lucy on the Sky with Diamonds. But honestly,
The girl,
that was
okay,
long conspiratized that it was about that. John Lennon did an interview saying it wasn't about that, but you know those guys were doing something.
Yeah,
Whether the song was about that or not is
it was
separate.
definitely about that.
I mean, I don't know.
I don't care
He was
what he said.
probably on something when he wrote it. Let's be honest. But
John Lennon was probably
well,
on something when he said it wasn't about LSD.
I think
yeah.
he's also given us a lot of clues there when he says, Lucy in the sky with diamonds. Like Lucy is actually Lucifer, the light bearer. So he's actually talking about how our whole solar system works. He's saying that, the solar, Lucifer in the sky with diamonds. Um, Maybe there's something in that too that explains why the stars appear to go backwards in the southern hemisphere. But I've created videos on
We
that.
have
It'll take
gone
me
in a
out.
totally different direction. That was not that was not what I
Well, you brought
expected
it up.
this
So.
to
It
go.
makes sense to me, Ryan. I don't know what you're talking about. That
I
made
just
perfect sense.
I just enjoy the Beatles. I'm sorry. All right, so Jiffy Jiffwald says if the Earth were flat, theodolite zeniths would not diverge. They do diverge. Ergo, Earth is not flat, and it is indeed spherical.
He's talking about reciprocal zenith angles. Iron Horse.
Yeah, I still don't understand. Is he saying like if you drew a triangle on a ball, it adds up to more than 180 degrees?
No, he's saying
No.
like if you have theodolites, right, and you have like a plumb line there, like a vertical line here, what you will observe over a distance is that those plumb lines will diverge. Your angles will not be 90 degrees like they should be on a flat Earth. They'll be diverging.
Okay, and this has been observed, has it?
Yes.
I
You could
don't
actually
believe
do
you.
it yourself. It's pretty cheap to rent two theodolites and go out and do this yourself, and you will measure a divergence.
But wouldn't you need a third? Well,
No, just two.
why do you need two?
Because a theodolite is just measuring the angle. So all you need to measure is these angles from the plumb bobs of each theodolite to a straight line to the other theodolite. And then they should be 90 degrees for each of them if the Earth is flat. But you'll find that they always add up to over 180 degrees, meaning that each one of them is more than 90 degrees, which is what is predicted on a round Earth.
Okay, that's a new one on me. I'll have to look into that one. But
Look
so
up,
far as I'm concerned,
here's the
you're
keyword.
probably
Sorry.
you, yeah. So far as I'm concerned, you're probably not factoring in the fact that over a long distance you have such things as perspective and convergence. And if you're not taking convergence in because you're doing it purely on a optical observation, then you're not accounting for all the different possibilities that might explain what you're seeing.
All right,
You
last word
can
ever.
account for each and every single one of those possibilities. You will still observe the same thing. And just so you know, if you want to Google this, it's called reciprocal zenith angles. So that's what you should Google. And I really would love for you to do this yourself.
All right.
I'll look into it.
let's carry into the next question. And Kaim, I don't know what I Am the Walrus is all about, but
Drugs.
it could be about drugs, but maybe it's just somebody has no depth perception. Because have you ever seen walruses just jumping off a cliff ruthlessly in a nature documentary? It's
Tying to
horrible to
that, I
watch,
will respond
but it's
cuckoo cuckoo.
cuckoo. It is cuckoo for cuckoo for sure. Uh,
Cuckoo
st-
cuckoo.
Stop triggering me. All right. Maximilla Villa says, oh, Ross, please explain what a non-physical molecule is. No more Beatles references in the live chat. You got to stop that, guys. It's just distracting me.
Well, it's a fine line between states of matter, isn't it? Like even water, for example, can be all three: solid, liquid, and gas. What do you call physical? Physical is obviously something of physics. You can weigh it, you can feel it, you can measure it, whatever. Gases, generally speaking, I would describe as non-physical simply because you can't see them, you can't really weigh them until maybe you compress them into a container. And you can't really feel them unless they're blowing in your face. So, yeah, it's a fine line.
I feel this right now. I feel the air. It's physical.
Yeah, and you can feel light as well. You can feel the heat coming from
It's
light. So
physical
where do you
too.
draw the line?
Yes.
So where
That
do
is
you draw the
also
line?
physical.
Everything is physical. Yeah.
That's physical too. Light photons are physical.
Yeah. But you're going to do more damage, hitting your face into a brick wall than you are walking through air. So, technically speaking, you got to draw the line somewhere
Completely irrelevant.
Between what is physical and what is not physical. And generally speaking, the way we move through air, we would consider it to be not physical, relative to everything else.
No one would do that.
But yeah, well, it serves no purpose to think of it as physical. It's
everybody in the world is in agreement that air is physical. Everybody.
Yes, but it may as well not be for all intents and purposes.
Oh, no. It may as well be
getting down to semantics. We're getting down to semantics. We've been here for over 3 hours. I do have other things to do in my day. So if we can sort of just not get bogged down on semantics would be great.
Cool.
All right, let's move into the next super chat. I feel like making Beatles references in between. That gives me something to do, right? If nobody's going to keep me preoccupied in live chat. So I feel fine. Jiffy,
I know you might have
you feel fine.
We can just get through the questions without the Beatles references.
No, you can't. You can't. I was going to say, I'm getting it. Nobody's giving me anything in the live chat. And if you entertain me, then I'm just going to keep prattling, Grayson. That's how I go. Jiffy Jiffwald says, if Earth were flat. No, I already read that one. Hold on. I never get tired of watching Ross. This is the one I was going to read. I was trying to pat at Grayson because some of these are just not polite. He's a laugh a minute. Would love to have a chat with him if he would stop talking long enough. Come on, Ross.
Well, we're talking complex subjects a lot of the time, and most of the time I'm barely even scraping the surface of them, especially when coming from it from a whole new angle, which basically flat Earth is redefining a lot of things in physics. So you can't just always give a very short and concise answer to something which really would require a whole chapter of a book to give it justice to. So I do my best.
I was doing my best to make that more polite, but Grayson, if you wanted to respond, you go ahead. Grayson's ready to move on. Well, thank you, everybody, for the super chats. Let's see. Gravity has fulfilled the burden of proof. Loss, LIGO, Cavendish, Shelion. A lead ball put under a weight on a spring scale to increase the registered weight. RDD has not fulfilled the BOP. That's from Jiffy Jiffwald.
Okay, I think I know the one he's talking about where they've put a weight beneath a suspended scale. But again, a scale sort of depends upon having the resistance factor there in the first place. And when it's suspended in air, by putting another weight underneath, you just basically change the air pressure beneath it, which could create that really, really tiny, insignificant amount of extra apparent weight, which isn't, again, it's not creating extra gravity. In fact, if anything, people say that gravity gets less when you climb a mountain. And he's basically gone and stuck a mountain beneath something and said it's increased gravity. So
let's do an experiment then, Ross. If you're saying that this is due to a difference in air pressure, then put the scale in a vacuum and do it again. And guess what? You'll get the same result, thus proving it is not due to air pressure.
Have you done that?
No, that's the prediction, is that you will get the same result. I'm making a scientific prediction.
No, you just made it as a claim. You didn't say you would likely get a difference.
I'm saying,
You just
let's
made it
do
clean.
this. Okay, fine. I will rephrase to make you happy because you said let's move on from the semantics and the pedantics, but now you want to focus on them because I'm talking. So we'll clarify my wording. I will make the prediction that if you do this in a vacuum with your weight in a vacuum, you will get the same results, and this will prove gravity and disprove your hypothesis. And we could do this, Ross. We could do this experiment.
Okay, let's do that.
Cool. Cool. And I just want to make the point that the amount of gravitational acceleration that you are experiencing is a result of the total amount of mass that is under your feet. So if you're in the ocean, you're floating on the ocean, and you go over an undersea mountain, the gravitational acceleration will be more than when you're over the Mariana Trench. And you can measure that difference, and submarines navigate our oceans using that difference. They have a gravimeter in them that's constantly measuring the acceleration of gravity, and they can navigate due to the differences in that acceleration as they travel over undersea mountains. That's a fact. Submarines are doing that right now.
I think that's utter hogwash. I've been swimming in the ocean all my life, and I find that whether I'm in shallow water or deep water, I have neither less or more attraction due to anything beneath me. I just float in water. And I think ships would feel the same thing too. They don't just all of a sudden sink further when there's more rocks beneath them. That's, utter nonsense.
All right, let's get back to where we once belong. If only you saw the live chat right now, Grayson, you would you would understand why I'm making all these references. All right, Earthly Skeptic, both I drop a couch from 39.2 meters above ground. A, how many seconds until it hits the ground? B, how many seconds until it becomes a social media meme?
69.
Oh, yeah.
What's he dropping? What did he say he's dropping?
He's dropping a couch, eh?
A couch.
From 39, I don't know how heavy the couch is, but from 39.2 meters above ground.
39.2.
How many seconds until it hits the ground?
This is something I really don't quite understand. I still think that 9.8 meters per second is just per second. It's not really per second squared, even though, I don't think it's accelerating that fast. So technically it should be about 3 seconds.
It's 9.8 seconds per second. Like 9.8 meters per second per second.
Yeah, but that doesn't mean that in the second it's now dropping 18 meters. And in the third, because that would be 18 plus 9 in just 2 seconds. Mm-hmm. And then you'd have to double it again, would be, or just add another 9.8 each time.
9.8 meters per second per second.
And the third second,
adding that
it's doing 30 meters. No, I don't think so.
You balance that out with the force of gravity is balanced out by the force of air resistance in the other direction. This is the same thing we've been getting on the whole time about you need to sum up your force vectors.
No, but it also works in the vacuum chamber, as we observed with the feathers and the bowling ball.
Yes, it does.
Don't start on that.
I'll give you the last word there, Grayson.
You still have a terminal. Your terminal velocity when you fall is a result of air resistance. If you don't have any air resistance, then you'll just keep accelerating the more you're under that gravitational force. There's nothing stopping you if there's no air resistance.
Okay, Let's move on to the next question. I know you guys can keep going, but Steve Ravel says...
How many questions do we have left, Ryan? Because it has almost been 3.5 hours.
Ooh, yeah, you are right. It's getting pretty late on the debate there. And you have been hinting that you want to get going. So we've only got 2 questions to go. Steve Ravel says, thank you, Grayson, for not leaving the debate. So Grayson obviously is getting near the end of his rope, everybody. So if you have a question...
I'm happy. I passed the bare minimum. I was here the whole debate. I didn't leave. I did the bare minimum.
The bare minimum. Some people do leave at the first sign of moderation, the minute I step in and say anything. And sometimes the live chat as well, they're looking to do their hero worship. So if I have to cut off their favorite speaker, the tears will start falling, and we need to get that modern day debate handkerchief out to those people ASAP. Fates says, who changes the sun's light bulb?
The sun is not a light bulb, it's an apparition of light, which is generally created mostly by our atmosphere. It's also created by a power source as it passes through our firmament, where it fuses hydrogen into the ocean of superfluid helium above. So it's always an orb of plasma shielded by the helium, which we can only see when we go in high altitude balloon footage. When we look at it from below through the superfluid oxygen layer called the ozone layer, it creates a disk of the sun. And then any of the other mediums in between can also create an apparition of light. We can even see it reflected in water. And ultimately, the sun actually appears 4 inches behind our eyeballs. So the sun has no height, no distance, no size. It's everywhere at once.
I completely agree with Ross because that sounded like the ramblings of a very grounded and sane man.
Thank you.
All right. Well, thank you to all of our super chatters and everybody for making it fun. I love the references. Everybody knows I love my old school rocks, so I appreciate everybody in the live chat for hanging out. And also to our speakers. What I like to do is do this UK style. Let's hand it over to Grayson. 1 minute on the floor. Give us your thoughts, closing the discussion, where everybody can find you, and maybe some other discussions you'd like to have on the platform going forward. But besides the Is Trump Good for America debate, because,
Cool.
excuse me, we know you want to do that one.
Yeah, so as we've seen, exactly like what I thought, the flat earth side of this debate has just begged the question, assumed that there's a downward acceleration at the start, can't explain why this acceleration is in the downward direction. They can't explain why that is. But gravity can explain exactly why that is. Gravity, under general relativity, makes testable predictions which have been verified to extremely high levels of precision. Like, I know people personally whose entire job it is to verify these predictions of general relativity. They are pretty precise. It is our most successful theory of gravity. Gravity is real. That is what all of our experiments, observations, and data combine to show us. So this was a fun debate. Again, my channel is called Based Theory, as in a well-based theory, or the opposite of a cringe hypothesis like flat Earth. So if you're interested in debates against pseudoscience like flat Earth, young Earth creationism, whatever, I cover a big amount of pseudoscience on my channel. Check it out at Based Theory if you're interested in more. And I've got several videos coming out about science communication, cool things I've done, like recently gone to Wyoming and found dinosaur fossils there. That video is coming out soon. And then also, of course, the debates against the pseudoscientists, the theists,
You've had more than a minute.
the young Earth creationists, etc. Thank you.
I was to say, if anything else you want to add there, Grayson, everybody can find you where? Where are you at right now? Did you say?
I said that already twice, but you can find it at my YouTube channel, Based Theory.
I'm sorry. I was reading the live chat. I had to just...
Well, you're saying how long I've been going on.
I
and
know,
how much
I know, but
up.
I set a timer, so I was reading live chat. I'm so sorry. We've always have to have this fun interaction every once in a while. Go ahead there, Ross. You have 1 minute on the floor for the inattentive mod here. I'm going to do my best.
Yeah, it's very easy to forget what I was going to say after that long rambling. What he calls assumptions are basic observations. Everything we do comes from observations, not from any sort of assumptions. The assumption of everything that comes from his still just matches the observations, but the observation was there well before any of the assumptions. Basically, he proves gravity exists because we got Cavendish, redshift, bendy space-time, dark matter, and dark energy all prove gravity, even though that basically takes up 98% of what gravity isn't. Everything about gravity is simply a made-up force that they have to have simply for the belief of the spinning space ball existing in the first place. If you don't assume anything that doesn't exist, that can't be observed, as we do with the flat Earth, we don't need gravity. It's superfluous. It just means weight. We understand weight works. Everything finds its place due to relative density, and there's no need to complicate such a simple matter. Thanks for hosting us today. You can find my channel, of course, under Iron Horse, where I have explained a lot of things I've slightly brought up here in greater depth and different topics. Described everything about the moon, everything about, what was that? Anyway, even the ISS, I've explained how that could work on the stationary planar Earth. And if you look at it, you'll see it makes sense. So thanks once again, and look forward to the next time being here.
All right. Well, you're both very welcome. And yeah, sorry if I had a few little gaffers there. I was at a 10-hour carnival with the kids today. We got there very early, and then we left, and we came back, and just it was a long, long day. So, the host is ready to go to bed here, and I'll put on
Cool.
the song that was sent to Tim the Ripper, who is a connection to the speaker that you're potentially going to be debating on Wednesday. How much padding language do I have to use there? But anyways, I'm going to put on that tune just to close us out because I like screaming at everybody. Once again, big thank you to Grayson, Iron Horse for coming out for the debate. You guys for your super chats. You guys keep the channel alive. Keep it going. We do hope that you tune in for that debate. We're going to try to get that set up. Is Trump good for America? You'll see Grayson hanging out on the screen for that one. So stay tuned, and we'll see you next time. Cheers.
No matter what you think of me. No matter what you think of me, it's only half of what I am. I'm the greatest, I'll set you free to say, and I won't give a damn. I expect complete conformity, or I'll cast you aside. I spit upon your decency and swallow up your pride. I must mean everything to you. Hear my call out to war. The fake news says now I'm a god who lives forevermore. Now that I'm everything to you, you might call out to war. The safe news says now I'm a god who lives forevermore. Wasting time, all of my life, living in a world of regression. Tyranny's mixed with self-oppression. What am I to do but tear away when I'm boiling at the top? Try to find a way to fight the fire, smart to rap from the minds of liars. Call the shots as you bow your heads, and the march never stops. The stars could be free, but this insanity bends you right by the knee. Running in circles now for something that can't be found. And I bet as you hit the wall, the rain starts to fall. You can run away, sing a tune that's true. I'll be beside you. Who's the one that holds you down? Push through there in your way, anything to make you stay. Cut the strings before your life starts to decay. From tears of blood, regrets of laughter, turn around as your heart beat faster. Your hollow shape as the faith begins to drop. Shelter can find your thoughts of suicide. It's hanging down by the fray. Running in circles now for something that can't be found. And there's no time for today. You prayed away that the world would be untrue. I will rise against you. Until they're gone, nothing can matter at all. Insanity bends you right by the nail. Running in circles now for something that can't be found. Out of breath, you smashed the wall. The water consumed all. You prayed away that the world would be untrue as it rose against you.
Yeehaw, we made it through, everybody. We had the debate. Glad to see that there's still, 180 odd people hanging out. Oh, more than that. Just shy of 200. So that's great. If you got any thoughts about the debate that we just had, we are going to have a comment section live in just a second here. I can't talk. Like I said, guys, I was at the carnival all day with the kids. I'm super tired. I'm super tired, Ryan. I got very little left to offer the world right now. But I am hanging out, and I see you guys in the live chat there. So I did want to just say hello. And I do appreciate you guys. It is really important that we have a live chat community that is partaking not only in the debates, but you guys are debating with each other in the live chat, and that's just endearing to see. Like, it's not just that we've had other people that have commented back and said, oh, hey, I've developed my debate chops not only from hanging out in the live chat, but also participating in our Discord. That just brings me joy. But like I say, just in general, just watching the debates. So, I think it's, I just let the speakers go. And I think the most important thing to take from these discussions is that whether you agree with the way that they unfold. See, I can't talk. I told you, I can't word right now. Wording is hard. But whether you agree with either of our speakers that are on screen right now, the most important thing is that you see how a conversation about these topics can unfold, and maybe make your own determination as to whether you'd like to have that discussion the same way as these people did going forward. So I just see, what is this? Sir Fev says Suppy. I'm not sure if you're talking to me. I know Teen Splayer, though, was you had a lot to say early on in the debate. I hope I won you over personality-wise. There's only so much I can do with the way that some people behave on screen, so I do my best to try to make it so that you guys have an idea of how the people would interact if they were in a room together. I hope that's what you want anyways. If you want this really chained down discussion where I just grab the reins and say, hey, no matter what you say, or if it's even just a little bit off the rocks, I'm going to take over and not let you do anything. I just don't know if that would be on brand with what we started out with as a channel at Modern Day Debate. So, yeah. Anyways, Ryan's going to get to bed. He's gotten so tired he's talking about himself in third person. All right, guys. Appreciate all the likes and the super chats. Let me get out of here before I make a tired fool of myself any further. So once again, if you haven't already, hit the subscribe button. I can't do any more housekeeping because I'm at the end of my rope. And you guys know where to find us, of course. Live Modern Day Debate. Both of our speakers that were on tonight, Grayson and Iron Horse, are tagged in the live description. We will see you next time. Good night.
depression. What am I to do but tear away when I'm boiling at the top? Try to find a way to fight the fire. Smart to rap from the minds of liars. You call the shots as you bow your heads, and the marching never stops. The stars could be free, but this insanity bends you right by the knee. Running in circles now for something that can't be found. And I bet as you hit the wall, the rain starts to fall. You can run away, sing a tune that's true. I'll be beside you. Starts to decay from tears of blood, regrets of laughter. Turn around as your heart beat faster. Your hollow shape as the faith begins to drop. Shelter can find your thoughts of suicide. It's hanging down by the fray. Running in circles now for something that can't be found, and there's no time for today. Prayed away, the world would be untrue. I will rise against you. Insanity bends you right by the nail. Running in circles now for something that can't be found. Out of breath, smashed the wall. The water consumed all. You prayed away that the world would be untrue as it rose against you. Did you think it would always be for free? Now sit back, watch it burn, burn, burn for all eternity.